Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. Emrys, thank you so much for the 6 months. Let me go ahead and put 6 Simul-Cows in the chat, and apparently a Simul-Wow as well. Simul-Cow, number 1. Now we just have how many more? 2, 3, 4, 5, 6. And then also a Simul-Wow, because that is also what you put down there. Super appreciate it. Nixie Tiff, hey, how are you? LLX or thank you so much for coming in, guys. Really appreciated it. Really appreciate it. And anyone who might be lurking in chat, hey, thanks for being here. So today we're doing something a bit weird. So in my endless quest to find things that are interesting for people to watch, I've recently found that okay, so let me just start at the start, right? So I've recently found that my channel could be spiced up a bit. We could do things that are more interesting to different people, right? Like, so what's a really hot topic? I don't know, quilting probably. So, like that's kind of what we're doing today. I actually became interested in this for a number of different reasons. So let me open this up and let's talk about it. Zent, how are you? I just placed one Simul-Cow with a Simul-Wow. Did I do? No, I did 6 Simul-Cows and a Simul-Wow, but that's okay. I really appreciate it. Thank you so much for all the support. Move over here, move over here. Okay. I'm sorry, I'm kind of all rambly and all over the place right now, but let me go over here and let me open up my YouTube channel really quick. YouTube.com. Oh, hello. User LeosOS. Okay. So, let me go to probably videos, and I imagine it's going to be in most popular and probably, oh, it's way down there. A long time ago, I made a video on color quantization. All right, let me post this in here. Now, the video did okay. 9,000 views at the time is pretty dang good for a video. Like, I had like 5,000 subscribers at the time. So 9,000 views is really, really good. The idea with color quantization is that you, man, look at my face. You take all the colors in the image and you basically minimize the number of colors that you're using, right? So for example, this is with 8 colors, and then, so then I changed it to 64 colors. 1 second. 256 colors. 512. 1024. And then, as many colors as I could manage. So I had a disclaimer in the description. Man, what was my disclaimer? There's so many different algorithms to perform color quantization. I thought this one was pretty cool. Oh, okay, whatever. Anyway, the point is that the way color quantization works is you kind of limit the number of colors that you have in your image. So again, this is with 8 colors. And so what I was thinking, okay, what if we just take any arbitrary image and we kind of cut the image in such a way? So, okay, I don't know how to describe this. Let's say we have an image. Here's an image of a tree, right? And let's draw a tree. Do I have a brown? I guess I have a brown, right? Select. So here's a little brown, and then we're gonna have like a little, green tuft up here, and then I don't know, it's gonna have a black thing in the middle that you can't see, but I promise is there, and maybe like, I don't know, orange roots for some reason. I have no idea. The point is, we take this tree, right? And what I want to do is I want to turn this into a quilt version of the tree. You have 16 million colors. That was the. I think my camera was actually not working very well for that shot. So like the number of colors in that shot was not as high as it was supposed to be. But basically, in order to turn this into a quilted version of, thanks for the things, the trees were nice, isn't it? In order to turn this into a quilted version, what we're gonna have to do is quantize the colors. Quantize. So we know we have a green, a brown, and like an orange or something like that. So we minimize the number of colors that we're going to look for. And then the next thing is we have to put it onto a grid, right? So to gridify. Now, when I say gridify, this is actually more complicated than you might think, because it's not just a simple grid. This is actually a grid with a kind of like diagonal component to it. So each of these grids can then be split up into like 4 additional components here. So it's like you have a set of pixels, and then you have a set of pixels that are offset. So you have 2 axes that you're looking at here. One, you have the 2-dimensional image of pixels, and then within each pixel, you then have an additional 4 elements for like up, left, down, and right. Up, right, down, and left. Sorry. Anyway, you have these 4 little triangular pixels triangles, which correspond to, these guys in here. So the question that I have is, can you take any image and turn it into something that looks like a quilt? I know that sounds really dumb, but I've been kind of questioning if this is possible. And then the other thing was, okay, after gridify, then you need to apply textures. So 3 is going to be textures, right? Because, if you're doing a quilt, it's not like you're going to be doing like purely, like a solid blue or something like that. Probably your blue has some sort of texture to it. So I'm wondering if you could like basically do the color quantization thing I did before, but then you could, for example, do an edge detection or something. So if this line is kind of smoothed out or something like that, so that like it ends up being like color quantization and then extreme pixelation, so that it ends up looking like I don't know how to put it, but it ends up looking like a quilt. Does this make sense? Like I'm trying to create like a filter or something like that. I know this sounds really lame, but I'm very interested in it for a lot of weird reasons. Hello, Internet of the Welcome Back Simulators to another episode of The Wonderful People. I added a the because it's so hard to read. I'm late. Hi, late. I'm TS Joff. Imps here, you're actually not too late. I started really late today. I had some meetings and stuff. I think pixels isn't the best term to use here, but oh well. Yeah, I didn't know what to call it. I was thinking maybe we could call it a trixel, because it's like a triangle pixel. I didn't really know what to call it, but I guess like a quilt square? What are they actually called in quilting? Quilt squares. All right. Not exactly what I was looking for. Like, what are they called? How big should quilt squares be? Nowadays, most quilt shops, both brick and mortar and online, sell a variety of pre-cut squares in packs. Sizes may vary. A pixel doesn't have to be a square. You're right. I mean, you could define a pixel as an arbitrary point, quilting terms. I'm actually really excited for this. I know it sounds really lame, but like, I'm kind of taking the afternoon off and just doing like a programming challenge that isn't related to work, because I've been doing like basically all of my streams have been revolving around work stuff. And don't get me wrong, that's fine. But also sometimes you just want to do a cool project because you think it's cool. And it doesn't really matter if other people, they're just called triangles. Yeah, we could call them triangles. Yeah, why not? Triangles. Um, um, so I guess the question then would be, are we thinking of this then, if it's a set of triangles, right? Are we thinking this is a square grid or a diagonal grid? Ooh, that was a bad diagonal. You know what I mean? So here are pixels. One here, one here. Ooh, I'm doing a very bad job of this. That didn't work out at all. But pretend this is a straight line, and that's also a straight line. Okay, and pretend those are parallel. I think we'll call them triangles. A quixel? A quilt elm? I like that one. I might call them quixels, because that's a nice name. Okay, so no Julia. We might do Julia. I'm trying to think here. So we already have color quantization working in C++, which is fine. Translating this to Julia isn't hard. The gridification here, I'm not sure what we're going to have to do for that step. I'm going to guess that we're going to have to do some weird step convolve thing. So I can imagine if you have like, okay, so it could also be, is it a 3D textures company? I don't know. So we have to do some sort of conversion from pixel to, again, I'm just going to call it quixel. Right? So this conversion from pixel to quixel, let's just sketch out what we think we're going to need here. So we're going to need journal, new page before. So obviously functions we're going to need. We're going to need one for color quantize. So color quantize, which is going to take the image and is going to take in the number of colors that we want. Okay, now we want pixel to trixel. What? It's not called trixel. What is it called? Quixel. There we go. Which is just going to take the quantized image, so quantized image, and then it's going to take, I guess, the size of each square. I looked, they're technically called quarter square triangles and half square triangles if you're just splitting pixels in half. I see. So in that case, quarter square triangles, quixel, I think it still works. It is Quixel Megascans, basically textures, normal maps, and so on from 3D scanning environments. Ah, okay. Quixel is cooler though. I think it sounds cooler, right? I don't think we'll have any copyright complaints if we call it a Quixel, right? Like I doubt we will. So the pixel to Quixel will take in a quantized image, and then I guess the size of the of um um how do I Quixels makes it sound high tech. Right. So we'll do size of, I guess, in terms of the number of pixels. So, like, for example, 1, 2, 3, 4 pixels would make a trixel that look, well, let's say add one here. So this would make a trixel that looks like this, right? So if we say, I guess it's a size and it has to be an odd number, I suppose. I'm not really sure. We have to figure out how we're going to do that. Okay, so the question is, do we output? So my question here, I think color quantize is easy. We return the quantized image. Okay, so pixel to Quixel, the question is, what do we return from here? Do we return? So, do we return another set of pixels that? Do we return another set of pixels that just does the averaging? So, for example, if we have, again, here's our Quixel that we have here. It's a set of these pixels, and so we're just going to say we're going to make it so all of the pixels in this triangle are essentially going to be the same color. I think that's what we need to do. We're going to say these are essentially the same color as the mean, or we'll say quantized mean of all these guys in here. Now the question is, do we do the pixel to Quixel first, or do we do the color quantize first? I think that's kind of up to the user. I know how to do color quantize, so we'll be coding color quantize first. But I think pixel to Quixel should be easy. So what was the third thing that we need to do? Adding textures. So that's the step. I'm not exactly sure what to do. So texturify. I don't even know if we really need to do this, but I think it's going to make like a really, like a much higher quality, like animation for the video if we could apply like an actual texture to our Quixels, you know? So yeah, Amara, sorry that, you came in so late, or rather I came in so late. Tomorrow I'm hoping to stream for a bit longer. Again, I just had a meeting at 4 o'clock today, so I ended up having to, it's been a rough day, but that's okay. I hope you have a wonderful evening. Have a good night's sleep, and I'll see you tomorrow. Okay. So the question is, how do we do the texturify? That's my question. What I'm gonna say, actually, this is probably also going to be relatively easy to do, as long as we can output a set of RGB values. What we'll do here is we will basically say we have some sort of pattern, which will be some other image, right? It doesn't matter what the image is, but some other image. And we're just going to say, if we just go through all the pixels, and then we just say, if this pixel here corresponds to this image, then we just replace that image element of I, whatever it happens to be, is going to be equal to the pattern of I, something like that. Do you actually want each triangle to be one color? Couldn't you maintain some texture by scaling them all to a range around that mean, so they're all a similar color or a fixed hue or something? Seems like you lose a lot of resolution. Yeah, you do. You lose a lot of resolution. This is why, like, I'm genuinely curious as to see, like, this is why I wanted to do it. I wanted to see if it was possible to, like what kind of images you could actually do here. Like, could we turn a dog into, like, a really, like, cartoony dog? Like, let's say we just take a picture of, like, a Shiba or something like that. Like, these have a solid, like, kind of orange color and a white color and a little black nose or whatever. Like, could we turn a Shiba into like a quilt version of said Shiba easily? I don't know. These are questions that I had. But yeah, you lose a lot of resolution, and I'm not sure the best way to do it. Do you want each triangle to be one color? So the reason we want it to be one color, yeah. So okay, you're right. We don't necessarily want it to be all one color, but we need it to be all from one pattern. And the reason we need it all be from one pattern is that you have to sew this up eventually, right? And if you're going to sew it up, you only have a limited set of colors available to use, like only a limited set of fabrics. So the Texturify is actually like more like fabric application, is what it is. So that's kind of what we're talking about here. Maybe some low poly algorithms could be interesting to look at. Yeah, I was also thinking about that as well. But then I was thinking polygons or these low polygon, algorithms and methods and stuff like that for like triangulation and stuff like this. These are used for. Are they used for 2D textures? I'm not really sure. So I just kind of wanted to, I don't know, mess around a bit, see what we can do. The other issue with triangulation, whatever it's called, is that these triangles have definite, like, they must be, what triangle is it actually? So this is a 90-degree angle. So then this must be 60-60. No, it must be 30-60. So I guess these are 60-60-60 triangles? No, is that right? Is this an equilateral triangle? Has to be, right? Yeah, it has to be. Yeah. So it has to be an equilateral triangle. And so because of that, it, no, that's not equilateral. Is it? Am I dumb? One second, we take a square. We split it here and we split it here. No, I'm wrong. This is a 45-degree angle. This is a 90-degree angle, and this is a 45. So it's a 45, 45, 90. Isn't it? Kelly Cheer, thank you so much for following. Really appreciate it. It has to be 45, 45, 90, right? I'm like at least 20% sure, which is relatively high for me. Okay. One second. Well, good. We're learning one small step at a time. Okay. So I think that's okay. So I think this is kind of what we're gonna do. So we're gonna start with the color quantization because that's easy to do and should be hopefully pretty quick. I say easy to do, but also I've completely forgotten how to do it because of course I didn't write an algorithm archive article about it because I'm what you might call dumb. Okay, so let's keep going. So we're going to CD into project Simuleos. Do I have a color quantization? CD color, there we go. All right, this is back when I cared about my channel. So, we have a color quantization.py. Do we now? How did I do the tree structure in Python? Quantize? What did I do for the tree structure? It's not there. Okay, let's go into vi color quantization.cpp. Let's see what we have. So in my main function, I literally just have quantize 512. That's easy enough. Let's look at the quantize function. It's there, and down here. Okay, so it's void quantize. This seems easy. We'll see. If you have to pick textures from a fixed set of them, won't doing quantization first make it harder to pick the best texture? That is a good question, and I don't really know the answer to it. I am afraid that... Okay, so the issue is when you cartoonify things, right? When you cartoonify things, the most important thing to keep in that cartoon version of something are the edges of that thing. So I think there's something that we have to do in addition to the color quantization. So we might want to do color quantization and then addition some sort of edge detection so that we can more easily highlight, the edges of something. I'm not really sure. We're going to have to think about that. The main thing is I didn't want to have like incredibly muddled colors, After watching your stream, I turned off syntax highlighting in Vim and actually got a 5% productivity boost. For the record, I'm not advocating that anyone turns off syntax highlighting. It's what I do. Simuleos is turning into a cartoon. There was this paper a long time ago. What is it? CNN sketch. Maybe No, that's not what I meant at all. Convolutional neural network sketch. There was a paper I saw a long time ago, and it was the first paper I had ever seen with anime in it. And it was about taking sketches of anime characters and doing the line work. It was so cool. If you want to avoid model colors, why don't you just, wouldn't you be better off just picking the mode color in a Quixel? Um, yeah, I agree. Yeah, picking the mode color is yeah, right. So we might not want to do a mean, but that was why I said quantized mean, because the idea I wanted to find a mean, and then after finding the mean, I was going to switch that to the quantized color that's closest to um that color. So the hope was that with color quantization, I can find like the top 8 colors or something like that. And then after finding the top 8 colors, I could then go through and use those colors. So we find the mean and then find whatever point's closest to that mean, and then we use that color for that quixel. We could experiment with different means. Geometric could be interesting. Right, definitely. Like, there's a bunch of really cool things that we could do here. And I know this, like, I personally think that this is probably one of the, like, I don't know if it's cool or not, but I think it's cool. Uh, this also has anime. So feel free to link any papers you know of that have anime in it. Waifu 2X? Oh boy. Of course it's Miku. Oh man. Hatsune Miku. Okay. So what do we have here? We have let me read this quantize function. So we have ooh, hello. So we have the image file, which is going to be our in file. We have C image of float is equal to the image. We have vectors, which is equal to pixel vector is going to be image read. So it's going to be the set of pixels that we have. We're going to be making the octree, and that's just by doing make octree, and then we divide the octree. Fair enough. Okay. So let me see if I can remember how color quantization works. Shall I? Okay, so here's the idea. We have some sort of image. Okay, not what I meant to do. We have some sort of image. And in this image, we have a bunch of different colors all mixed together. We've got, oh, well, try doing. Okay, also not what I meant to do. Here we go. We have like red over here. Somehow leaves the image. Blue, I don't know, dark green, yellow. Then I'm sitting here in the center. I don't know. This is an abstract representation of my thoughts or something like that. The point is what we're going to do in order to quantize the number of colors in the image is we're going to take this image and we're going to split it up into a bunch of pixels, right? So, you know, it's going to be like we have a yellow pixel here and then a red pixel and then we have a, I don't know, a green pixel, and then I'm just going to do a 3x3. Well, let's do 4x4 image. And I'm just going to like kind of put these guys, you know, somewhere. I don't know. I'm just drawing them at random to have all these different colors. I don't know. Sorry, I don't really know what I'm going for here, so I'm just drawing like a bunch of colors. And here's our poor representation of an image here. And so we're going to do, I don't know, yellow and yellow down here. Don't judge my color choices. I just chose something. Okay, so because it's a two-dimensional image, what we're going to do is we're going to first create a box that encompasses all of the pixels. And we're going to make this box white. So it encompasses all the pixels. Then inside of this box, we're going to then split it up into into a quad tree here, right? And so what we would then do is to find the 4 colors, we would average 1, 2, 3, and 4, and this would then be the set of 4 colors that we use for our image. Okay, so then let's say we wanted to do, I don't know, 16 colors. Well, if we were going to do 16 colors, what we then do is split this up further into even more boxes. So this would split up into this, and this, and this, and this. I think that's right. And now every single pixel has its own color. And the idea is we basically just turn the image into a quad tree, and we, we just, I think I'm doing this wrong. I think I just realized how I'm doing this wrong. I'm so sorry, I'm dumb. I'm an idiot. I'm trying to remember how we did this, and it's been a while. I should have just watched my video on this. We don't do it this way. we actually create a three-dimensional RGB space. Oh, that didn't quite work, did it? Let's try that one again. So we do, when I read the title, I immediately thought of coding up a cult. So it's RGB. Okay, and then we plot each color based on its RGB value. And then after plotting each color based on its RGB value, we then create an octree of that, which is it's the same thing as a quad tree, but it's now an octree, so it's splitting up into 8. And then after that, we then find the mean colors. And then after finding those mean colors, similar to what we said over there, we then take every single pixel in the image and we basically map that back to the colors that we have decided here. Oh man. Hopefully we can do this. I'm trying to remember exactly all the details. So I'm just hoping to get this done in the next hour. Like now I went from, oh, octrees are easy, everyone can do this, to I've completely forgotten how color quantization works in the matter of 5 minutes. So let me just read our C code. So we had tree, octree blender output, quantize color, when does an entropy calculation on Simulaios' randomness. Okay, on a physical level, I have a lot of randomness, right? Because surely there's a lot of entropy just going on in my body, right? How would you calculate entropy of thought? So let's say you have. So usually you define entropy as some sort of measurement of. Okay. Actually, entropy of thought's super easy. Wait. Journal new page before. Entropy of thought is really easy. Okay. Entropy is a measurement of. Entropy is a measurement of. Essentially. You have microstates, and you have macrostates, right? So, like for example, if you take a coin, you can flip it, and you're either going to get heads or tails, right? Or you could, if you flipped a coin twice, you could heads, tails, or heads, tails, or tails, heads, right? So we could plot this, for example, as saying we have tails, some combination of heads, tails. So this is heads, tails, or tails, heads. And then we have heads, right? And so this is going to create a bell curve where you're more than likely to get some sort of combination of heads and tails than you are to get heads and heads, right? So that means that you've got a chance that it looks like this, chance that it looks like this, and a chance that it looks like this, right? So it's going to be 25%, 50%, and 25%, right? So your entropy of thought would have to be related to how is some sort of measurement of how your microstate, the individual thought that you're on, is related to the thoughts that everyone else is on. And then I think that would be how you'd measure entropy of thought. So if you wanted to go down that route, I think that's totally doable. Anyway, that was a tangent. Tangent number, I think only one. We're only one tangent today. That's not bad. I did program quadtree. Humans are horrible at randomness, and it wasn't thought. It was your colors in the order of HTEM. And what about edge cases where it lands on the edge? I am not entirely sure I understand what you mean by any of those statements. So let's just kind of go. I will be doing this in Julia. I'm sorry. I know I kind of have been saying that I want to distance myself from Julia, but at the same time, let's just do it quickly, and I think we can just knock it out. I don't think it's going to be too long. So let's cd back a directory, and I'm going to make a new directory. In fact, we could turn this into a package. And maybe that's what we do. Maybe we turn this into a package. Would anyone be like pissed off if we did that? I'll call it quiltify.jl, and literally all it does is take an image and turns it into a quilted image. Yeah, let's do it. Why not? So I'm gonna run Julia. I think it's generate package. Yeah, generate quiltify. Sure. Generate quiltify. Okay, so now we're going to Ah, okay, I see what I did wrong. So let's go ahead and move quiltify. I thought it would automatically add the JL to quiltify.jl. CD into quiltify.jl, ls here, ls source. Okay, so now let's create the repository on GitHub, github.com. And let's just do it. So we're going to create a new repository. Okay, and we're going to call it quiltify.jl. A package to turn images into quilts. Sure. It's going to be public. We're not going to add anything to this right now, just because I'm creating a null repository so I can add it. So let's go over here, and now we're going to do git init. Sure. Okay. And let's go vi readme, and we're going to say quiltify JL, simple package to transform images into quilts. Okay, I know this sounds really lame, but I also wanted to kind of make a quilt of like some of the domain colored images that we had before, because I thought it'd be really cool. I don't know. I mean, like obviously someone has to like sew up the quilts, but that'd be like a really cool thing as like something to sell, like, you know, like as like Simuleo's merchandise or something like that. If I ever went down that route, I thought it'd be kind of cool. Okay, so we've got the README. Let's add in the license. I'm just gonna CP a license here and change this to be 2020. Perfect. Okay, so we've git inited, git remote, add origin math, git remote add origin, and then we have to give the URL. Yep, here we go. Perfect. Now we're gonna do git push, origin, git add, sorry. Dot git status, git commit -m, adding project structure. All right, git push, origin master. And again, guys, if you have any comments, questions, concerns, ideas, feel free to let me know, and I will totally address it as soon as I see it in chat. Hopefully, yeah, okay. So this is push. Now let's do git branch dash, git checkout -b, and we're gonna say development. Look, I realize a lot of people get kind of a bit antsy at how I do development, but I always do development on like a separate branch to keep the master commit history clean. And so like a lot of times you'll go to like projects that I've developed and like there's nothing on the master branch and people get confused. It's just because it's all in a development branch somewhere. And so like there could be like one commit on this particular package for like months. And then like one day I'll just push it and it will have full functionality. And that's just kind of how I do development, because I don't really like people, I don't know, I guess I don't like people snooping in on how I do the development and stuff. So we're gonna CD into projects, quiltify, L is here. So let's run Julia --project. All right, and now we're just gonna do add revise. In this way, if we modify quiltify source code, we can just kind of mess around with it a bit. Let's go into vi source and then quiltify in here. Okay, so if we do using quiltify, then we should have our greet message and everything available. So the nice thing about revise is that we don't have to recompile. It actually makes it it makes it easy. Again, if you guys have any comments, questions, concerns, anything like that, feel free to let me know. Okay, so for the module quiltify, I think what I'm going to do is I'm going to create a separate file in here. So let's go ahead and vi source, and I'm going to call it, should I call it quantization.jl? That's what I'll call it. Quantize.jl. Sure, that'll do. And we're going to do, I think what I'm going to do is I'm going to go into quiltify.jl, and in here we're going to do include quantize.jl, I think is what I called it. And then in here we're going to do using images. Is there anything else that we need? Let's go over here. Using quiltify. All right. And now we should just have the greet function available. Maybe it's quiltify.greet. Greet. Yeah, there we go. Perfect. Okay, so we're going to DD there. We're going to include quantize. We need to be using images But what else do we need to use here? Um, I'm not entirely sure. I think what I want to do. So I wonder if I should. I don't know if I should create like a submodule. Well, let's just mess around with this a bit. So we're going to right and quit here, and we're going to go into vi source quantize.jl, and in here we're going to create a function, and we're just going to call it quantize here, and in here I'm just going to do print line hello world exclamation mark there. Perfect. Okay, so now we're going to do. I should be able to do quiltify.quantize, I think. Now, of course, that doesn't exist. Write that, go over here, using Quiltify. Now we try Quiltify dot and see what we have available. We only have greet, include, and eval. Okay, let's do Control D. Open up Julia again, using revise. And now we're going to do using Quiltify after that and see what we have. Okay, so using Quiltify. Load error extra token images after end of expression. Failed to precompile. Oh, that's probably because I need to add images. Right. Okay. That would explain that. Give just a second. It takes. I don't know why it's taking so long to add something to the manifest and project, but it's okay. So I think the goal for the end of today is to get some sort of color quantization working. And then after that, we will focus on, I think, honestly, we can probably knock this out if we just come back tomorrow and we just like knock it. Like we just do a long stream and we get all this Quiltify thing done. I think we can get it done in like a day if I just work on it. But I think for today, we're just going to get the color quantization out, which is somehow the hardest part and also somehow the easiest part because I've already done it. And then after that, we have to create the other functions. So I guess I'll go ahead and create the skeletons for those guys. So we're going to do vi source. So we have quantize, and then we have, what were they called? Gridify, which I think we changed the name for grids to be quixels, right? So I'm going to call it quixelate. Quixelate.jl. And this is going to be function quixelate. And this is going to take some sort of image. And then quixel size, right? And in there, and here we're just say function to convert image pixels into quilt quarter squares. Squares quilt pixels. Here called quilt pixels or quixels. All right, perfect. Okay, so we have that down. So now the last thing we need to do is texturify or something like that. So let's do vi source, and we're gonna call it. I called it texturify, but in fact, probably I want to call it something like fabricify. Oh, this is so dumb. I'm sorry. This is so dumb. Well, yeah, whatever. Quantize, quiltify, whatever. Fabricify is what I'm going to call it. That's what we're going to do. .jl. All right. And here we say function, make texture, add, apply. Quilt is already a verb. Yes, it is. It is indeed. So you're saying instead of quiltify, I should have just called it quilt? I just feel like quilt being used as a verb doesn't make too much sense in this case because we're transforming an image into a quilt image, right? So because of that, like I think quiltify is still fine. I'm just gonna call it apply. We'll say fabric pattern or something like that, and it's going to take in the I guess it's going to be the quixel image, and then it has to take in the fabric fabrics here. And then here it's just going to say end, and this function to transform every pixel in of a quantized color into the fabric variant. Let's see, of that color. Okay, sure, that'll work. Stitch. Yeah, so we're not doing any stitching here. We're not doing any, the mechanics. If we're gonna make a quilt from this, I'm gonna have to do the quilt by hand. Here we're just taking images and turning them into a quilted image. I think it's gonna be a cool effect. I'm actually pretty excited for it. Be quiltify. There's a lot of that. So let's do rank quit. So now we're at the quantize stage. So let's go ahead and do using. Oh, actually, let's go back into VI source and then quiltify.jl. So we have here, and what did we call them? I think we called them Fabricify. It's the dumbest name ever. And then also Quickslate. Right? Yeah, I think that'll work. So if we do using Quiltify in here, images after end of expression, okay. Right. Try that again. Fabricize, that makes more sense. Let's change it to fabricize. 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 And now let's go ahead and move source fabricify into source fabricize. Perfect. Okay, this is how programmers name things. I don't know. I mean, this is peak naming conventions here. You guys probably just don't understand. Like, I know you guys are probably looking at these names and you're thinking to yourself, man, these are some stupid names for variables. But I think you just don't understand like what peak naming performance means. Like, this is, by far the best naming convention I've ever created. All right. It's taking a while to precompile Quiltify, probably because it's taking a while to precompile images. Could not open file, Quiltify, source, Try it again. You don't use varying lengths of underscores for names? Variable 1, x. Variable 2, underscore x. Variable 3, 2 underscores x. More than 2 characters, too inefficient. There are only 2 hard things in computer science: cache invalidation, naming things. Wait, what? You missed the off by 1 errors. That's like the whole joke. But no, I appreciate it. So let's go into VI source quantize, and we're gonna do it. We're gonna create the function to quantize an image. So what is this gonna take in? It's going to take in an image. DD here. So I suppose we should actually create a number of different functions. Let me think. How do we want to do this? I've been having difficulty trying to make partially frozen data class, and I'm honestly thinking I'm gonna stop trying and just use type hint instead. Do what you need to do. I mean, if it's a matter of, I always get frustrated. This is maybe a side tangent. I always get frustrated when there's like a particular element to a programming language that like everyone seems to understand but me. In the end, more than likely, I wasn't the only one struggling to understand that concept. At least at a deeper level. So if there's like something in a programming language that you feel like you don't want to use, no one's forcing you to use it, Anyway, this is also, again, a side tangent. It's not directly related to what you had to say. Okay. I suppose here we're just gonna have to read in an image. So we're already gonna have that image set. I'm just trying to do something really weird and unintended. That's probably fair. There's 2 hard problems in computer science. We only have 1 joke and it's not funny. Oh man, that was harsh. Okay. So for quantize, what are we going to do? We do know for a fact that we're going to have a function to make octree. All right. So here we're going to have this, and I suppose we're going to have to read in the image as well here, because the image is just a set of pixels. Ooh, this is going to be, how do I do this in C? Okay, this is going to be a pain. Peak naming would be calling the file the sewing emoji. We could do that, but I'm not going to. Because it doesn't work in my text editor. Okay, right. So I'm going to create some sort of struct up here, which is going to be struct, and we're going to call it, should we call it, I want to call it node, because everyone wants to call these nodes, but, you know, we've been doing such a good job at naming so far. I don't want to ruin our naming convention with something normal, right? Okay, so what are we going to call the struct? The struct is going to be, I'm just going to say it's going to be color node. Okay. And then in here, we're going to say it's going to take in, it has to be an RGB value. And it must have a set of neighbors as well. You know what? I'm gonna open up our old C code, and we're just gonna modify this and work off that. So cd into project Simuleos, and then color quantization, L is here, vi color quantization.cpp. And let's look up what we did for, was it in the header file? Probably in the header file. Okay, so we had struct particle, and we had struct node. So the particle had, why did we have a separate particle class with a velocity and all that? Oh, it was for the center of mass. Okay, I understand now. Right, okay. Right. I understand now. Gotcha. Basically what we did is we plotted each individual pixel on RGB space, and we called that a particle. And then we found the center of mass of that particle. So want to use emoji code? We have some emoji code in the algorithm archive. So I've struck node in here. It's vector P, which probably stands for pixel. Then we have, let's see, an array of children with 8 elements. Yeah, that's exactly what I expected. Yeah, it is an array of children with 8 children in each node. So I'm going to open up another terminal, and sorry for all the terminals. It is what it is. Sometimes life gives you lemons, and when it gives you lemons, you open up more terminals. That's just what you do. So we're going to cd into project Simuleos, and then epidemic. L is here, and I'm going to go into vi graph test.jl, because we literally just created the same node, the same struct that we needed yesterday, and this actually worked after some testing yesterday. I just failed miserably at life during stream, but afterwards I had to sit down with my roommate who said I was an idiot, and then he mentioned that, if you would have just done this the right way instead of being a complete moron, you would have gotten it correctly. He said it in much meaner terms. I'm kidding. He didn't actually say that, but lemons equals more terminals. Yeah, like my general philosophy in life is if a problem is posing a challenge, more than likely you just didn't have enough terminals open to solve the problem. Like that's generally my philosophy in life. So let's see. We have push, pull, wait. Okay, good. So yeah, I think this is all we need. Let's go back to our Julia code in here. We're going to call it a color node. And this is going to take an RGB value, which is just going to be, I guess we're going to call it color is going to be of type RGB. There's sometimes an A associated with this, so we might need an abstract RGB, but that's okay. We're not going to worry about that for now. And then we need a set of neighbors. So we're going to say neighbors is going to be of type vector of color node. Okay, perfect. I think that's it. The speed at which one opens terminals equals terminal velocity. Oh no. Oh no. Oh man, that was really good. Back when we were doing the hacker typer thing, like that's what we should have called the speed at which you are typing in the terminal is a terminal velocity. Oh man, that's a highlight. That's a highlight of my year so far. Good job on that. Okay, so we're gonna have a set of nodes here. And I suppose what we need to do then is we need to make our octree. So let's see, how do we do that in C++? We have a make octree function. So let's go into make octree, which is going to be down here. And what did we do? We said SCD vector particle P, and then we had double box length, okay? And we said auto root is going to be new node of vector box length null pointer. Okay, so they're correct. What we need here is the color node. Actually, we're going to call this a color box. I know that sounds really dumb, but that's what we're actually doing here. So we're going to call it a color box. So what we're doing is we're again taking all the pixels, we're distributing them in RGB space, and then we're creating a bunch of boxes that correspond to um, all the pixels in the image. So why were computers cleaner back in the day? Everything is all GUI now. Um, I don't know. General rule of life is people don't know what they want. Yeah. Okay. So, man, I do kind of want to make that discussion video about how simple is not equal to easy to use. You know, Salt Farming, by the way, I do appreciate the follow. Thank you so much. For the same reason, computers were less intuitive and less capable. There are simply fewer features. I don't. Oh wait, I missed the joke. Why were computers cleaner back in the day? Everything is all gooey now. Oh, haha. Oh, I'm sorry, I'm an idiot. Oh, that's pretty good. Okay. I'm so sorry. Okay. So I guess what we actually need then is we're gonna have a set of RGB elements. So how do we know if each element is in each box, right? So again, what we're doing is we're taking all of the image, all of these colors here, and we're distributing it onto RGB space, right? So now we need to figure out, how do we know that n pixels, whatever the pixels are, n colors we'll call them, are in this box? The answer is easy, because I'm what you might call dumb. Okay, yep, this is super easy. So when it's easy is what I mean. Journal, new page before. We have some sort of box. Here, I'm just going to have R and B up here. So it's ranging from, the red value is going this way. So this is pure red down here. 1 second. This is pure red over here because there's no blue. This up here is pink. This over here in the corner is black, which I can't represent. And then up here in this corner, it's blue. Okay, so the idea is there's like a gradient between blue and pink. And then all we have to do is we just need to split this box up. So we'll just say anything greater than 0.5, anything greater than 0.5 is over here. So how do I put this? So 0, 0.5, 1, 0.5, 1. And so the idea is anything between 0 and 0.5 is going to be in this box. Anything between 0.5 and 1 is going to be in that box. Okay? So this probably means that we have to sort all of the pixels in the image based on their R, G, and B values, so we know where they fit. This is going to be kind of interesting. Well, the question is still relevant, to be honest. Definitely computers have gotten faster, yet much slower at the same time. Oh, that's something. I don't know, because I'm what you might call dumb is an interesting catchphrase for someone with a PhD. I think most people with a PhD actually have a similar catchphrase. Like, I realize that a lot of people tend to think that, folks with PhDs are maybe a bit arrogant, and they're, like, it takes a certain person to get a PhD. But I do feel like most people I know with PhDs are quite self-deprecating. Like, they tend to see themselves as, maybe not in a general audience, but at least among their peers, they tend to see themselves as, like, the least capable person in the room. I actually feel like, how do I put this? I feel like this is what's happening. Let me just drop down here. Okay. So, like, there's this curve. It's called the Dunning-Kruger effect. And I think it goes something like this. I think it goes something like this, or is that the negative of the Dunning-Kruger effect? Oh, let me just Google this. Dunning-Kruger. Yeah. I did the negative of it. My bad. But anyway, the point is that you have this thing where, like, if you know nothing about something, you just don't care about it. But as you start to know just a little bit of it, you begin to feel like you know a lot about it, and you become very confident in your abilities. After that, you start to realize you really don't know anything as you start to learn more and more, and then you start moving up to the slope of enlightenment and plateau of sustainability. So the idea is, If you know nothing about something, you don't care about it. If you know just a little bit about something, you tend to think you know a lot about it. Then as you learn more and more, you start to realize, I actually don't know anything. PhDs are usually somewhere on this slope of enlightenment, right? And they're usually dealing with people who are also somewhere on the slope of enlightenment. So you'll see people all the time that know more than you about certain topics and less than you about certain topics, right? But the thing is, everyone kind of understands that we're on this slope, right? So if you're used to dealing with people on this slope and you meet someone on this peak over here, you end up getting kind of, you get kind of miffed. Well, not miffed, but you get kind of confused because you are always self-deprecating to people around this slope because you know the struggle and you know what it's like to learn things. But when people are over here, all of a sudden you get really confused because now you don't really know, are they actually on the plateau of sustainability over here based on their confidence level? Or are they actually just really dumb, right? And this happens a lot. Sometimes like I'll be listening to people, I'm like, actually, do you know what you're talking about or do you not know what you're talking about, you know? Let me go ahead and catch up on chat here. Self-deprecating is super endearing. I guess I appreciate that. You're approachable, so it's working. I appreciate that. Oftentimes it's oftentimes a little is a lot. I've never really had this experience with CS, so I guess I'm still on the peak of Mount Stupid. It could be true that it doesn't exist for CS. It exists in academia. I'm king of Mount Stupid. If I know a little about something, I'd know more than most. That's also probably true. Never seen it with these names. You are wrong about this because... Why am I wrong about it? Please correct me. I love being corrected. Okay. So my point with this discussion is that with the Dunning-Kruger effect, and again, I accidentally drew the negative of it. Sorry about that. What is yolk? Oh, it's because PhDs, from what I've seen, tend to feel that they're the dumbest person in the room. So what they say is things like, "This is easy," because to them, if something is easy, right? If they can understand it, it must be trivial because they're so dumb. If they can understand it, it must be easy, right? And so this comes in my language. It happens all the time. I'll say that this is relatively simple. All you have to do is multiply by this, or you have to do this, or you have to do this. Like, because I don't see myself as particularly intelligent. So when I am able to figure something out, I tend to feel this is easy because if I can figure it out, everyone else should be able to figure it out as well. And this, to PhDs, is meant to come off as self-deprecating. Right. But what it actually comes off as, to people without a PhD, we'll say not equals PhD. I don't know how to notate this. This is easy. Comes off as arrogant. And that's the problem, right? So like that to me is the heart of the problem of why most people see people in academia as arrogant and maybe even self-centered, because what they see as being self-deprecating, asking questions, trying to understand the heart of things, all of these types of actions are typically seen as arrogant when you're outside of academia, right? Like I can ask my friends and peers questions that are stupid, like really stupid, and leading questions. Like for example, just the other day when we were talking about epidemic modeling, I was like, well, why don't we just use like actual epidemic protocols like this or this? Like why are we straying away from the known methods and stuff like that? And like, I was genuinely asking a question, but also this could be very easily interpreted as me telling them, you don't know what you're talking about. Why are you doing it this way? But that's not how it was meant, nor was it meant as a way to like put them in their place or anything like that. I was just genuinely asking a question, right? And so there's just this difference of people who know a lot and are in academia and people who know a lot who aren't in academia. Basically, experts have already moved past that plateau of or that, what is it called? Slope of enlightenment or whatever. So I feel like it's just a big issue because if you're over here, right, on the slope of enlightenment, you can very easily kick people off the peak of Mount Stupid, and you make them feel really dumb really quickly, and it's really a big problem, right? So if people are on the peak of Mount Stupid and they feel really confident about something, and then you ask a simple question and it moves them into the valley of despair, they're going to be pissed off. And that leads to them thinking that, oh, you're so arrogant, being so much smarter than they are, and all this kind of stuff. But that's not at all what was meant. Anyway, that was a long ramble for something that doesn't really matter. That's my point. Third-party Twitch client, what I found out recently, and I love this so much, you can actually just run MPV and then twitch.tv/simuleios, and I think, do I just have to get the full URL? Oh no, maybe I've screwed up. Let me check this really quick. Twitch.tv. I thought this would work. Does this work? Am I able to play my own Twitch stream? There's a commercial break in progress. What? Is there a commercial break in progress? No. There is not. Don't give me that. Okay, well, good. Unless you use cookies. This happens for every stream over MPV. Oh, really? So you can stream with Twitch just directly to MPV? Yeah. I don't know if I get viewership from that or not. That would be interesting. I don't know if I do. If you have YouTube DL installed. Yeah, that's what you need. Do I get... I must get views from that, right? I don't know. You don't get viewer numbers. Oh, no. So, it only says I have like 40 people watching right now. But actually, I probably have 400. Like, they're all just watching on MPV. I don't need all that. There is not a commercial break in progress. At least you didn't a few years ago. All I need is an ad. I'm not a viewer. That's okay. We are significantly behind where we want to be. So I'm going to... How do we want to do this? I feel like we're going to get a list of pixels with R, G, and B values. And we need to bin those pixels. So how about I just go down here and we create function, I don't know, bin pixels is what we'll call it. And here, what's this going to take in? This will take in our image, which again, is just a set of RGB pixels. And the question is, if we have a set of RGB pixels, do we need to sort it? Or do we just do the good old-fashioned... Maybe we just go do the good old-fashioned, just go through every element in our image and just figure out what box it's a part of. Maybe that's what we do. And we don't worry about it. It's not actually, but they expose IRC-like interface. Oh, yeah. I learned that recently, that Twitch chat isn't a pure IRC client. Okay, so how are we going to do this then? There might be actual IRC in the beginning. So each color box will also have a, I'm going to say a mean color, which is, oh, no, that is the color associated with each color box. We're just going to call it color. Okay. So then, I think this is what we need to do. So we're going to take our set of colors. We're going to split it up into X, Y, and Z. And so we could have like a number of different points that are between, like somehow between R, G, and B here, right? And then we just say, well, the center of mass of all of these elements is maybe here-ish for this guy, maybe here-ish for this guy, and, over here for this guy, and over here for this guy, or whatever. And so we can get an actual color that represents all of these guys. So yeah, I think this is what we need to do. So we're going to need a function to bin the pixels. Making the occ tree isn't so bad, but we need to think about the level depth here. So this might need some sort of depth parameter associated with it. Maybe that's what we need. I'll think about that. Yeah, no, maybe. So we have the set of neighbors, but I feel like we also need like some sort of length associated with the box, right? So we're going to split our grid in half. Well, actually, our three-dimensional color space into octants, and then we're going to split each of those octants up further. So this is kind of confusing. Right. So this is going to also take in a color box. So we're going to call it box. I'm going to say it's F-type color box. This is taking a lot longer than I thought it was going to because I have completely forgotten everything to do with color quantization. Let's see. I didn't know that. Let's see. It's not actually. What is Streamlink? Do you have to use Streamlink for Twitch? A real PhD would call it Mu. Wait a minute. What are we talking about? Call what Mu? I missed something. Um. Okay. So we're gonna have a color box, and I suppose we need the extents of the color box in some fashion. Um. So each color box should have extents up here or something. Which is going to be um which is going to be I want to say it's going to be a set of tuples. So R is going to go from 0.5 to 1, G is going to go from 0.5 to 1, and B is going to go from 0.5 to 1. So I want to say it's just a set of tuples. So it's going to be, can we do a vector? Or maybe a tuple of tuples? How does that work? Let's just mess around with tuple of tuple. Well, let's just do it. So we're going to say it goes from 0.5 to 1. And then it goes from 0.5 to 1. And then from 0.5 to 1. And then we're going to say extents. All right, is equal to this. What is the type of that? And why is it taking so long? Instead of mean. Oh, that's probably also fair. A dumb joke. When do you get window? When do we get window cam? By the way, we just want to see if there are any trucks here. I am so sorry. Window cam has died. It was an unfortunate end to an era on Twitch where I was able to turn my camera around and point it at a window, and there would be something interesting there, like trucks. But now there's nothing but a parking lot over there on my windows. So I'm sorry about that. I've been thinking about getting a chalkboard. It doesn't. There's no reason in that. I was just thinking about that. So let's do type of extents. It is a tuple of tuple of blah blah blah. So maybe I'll just say this is extents. Oop, hello. There, and we'll leave it at that. And so now we try extents of 1. Right. Failed to revise. That seems to work okay. Running the code does not match save version of the following. Okay. Revise.retry. Okay, I'm not exactly sure what's going on here. But let's go ahead and make the octree here. So we have the image that we're reading in. And I guess the idea is that we will go ahead and create the initial node. So octree box. Okay. So here we're gonna say box is gonna be equal to color box. And it's gonna take in some sort of RGB color, and I think I can just mean an image. I'm not exactly sure why that broke, and it's kind of freaking me out a bit. So let's just go over here, write this, go, ooh, hello. Which, Julie double dash project using images. Let's create an image, load it in, mess around with it a bit, and go from there. Did you show a parking lot or unsub? I'm so sorry. You can unsub because I'm not going to show the parking lot. Carl24K, thank you so much for following. Really appreciate it. Even though I'm not a sub, what's your thought on the phrase, those who can't do teach? When typically speaking, those who can't do often don't understand a given subject well enough to actually explain it. Or do I just not understand the phrase? Is it a dig at teachers? I think there's more like those who don't succeed in their field become teachers because otherwise they would have a career in that field. There is an unfortunate truth to that statement that is also unfortunately, I don't know, like, yeah, if you're unable to succeed in X field, therefore you teach X field, then you're probably a pretty crappy teacher as well, because teachers are really, really important. They are the like cornerstone to any modern educational system. So not having them or like, I don't know. So saying that you're bad at carpentry, so you teach carpentry, is a really bad thing to do. So it's like I don't actually know if in practice bad carpenters become teachers of carpentry. Like I don't know if that actually happens. I hope it doesn't, but I don't know. Um, so let's see. There are teachers that are really good at teaching and stuff, but they are few, unfortunately. And the wages and working hours and everything is crap. Doesn't make it better. That's true, specifically in the U.S. I don't know about other universities or other countries. I'm gonna rename basic function that's used across my entire code base. Wish me luck. Good luck. Um, it's that teachers' wages aren't particularly high, but money isn't everything. I think it's meant in the sense that those who know the subject but can't do it as a job for personal or physical reasons often teach instead. The example that jumps to mind is a football coach with a bad back. That's probably fair. Bad carpenter might be very good at carpentry, but not good at working with other people or dealing with clients and stuff like that. Yeah, that could be true as well, right? Like that could definitely be true. True. But also, I feel like a teaching job, I don't know. I feel like a teaching job encompasses also stresses that you wouldn't see in carpentry. So you have to be good at an entirely new set of like skills. So let me do a is gonna be equal to rand of lowercase r rand of RGB and then 10 by 10 or something. And now we just do mean of a using where is mean defined? I mean, I guess I could just do an average myself. Well, let's just do sum of a divided by, I suppose we just want to divide this by 100, and then that should be the mean values, right? That'll be fine. Good enough. Let's see. So then it can't actually do the job, or like someone who's retired. That's true as well. All thoughts worth pondering just was brought to mind from the Dunning-Kruger discussion. Yeah, fair enough. Or someone who is good at something that nobody is willing to pay their worth for. Like for instance, you. Oh, maybe. Okay. So let's keep going. So what we're gonna do here is we're gonna define the color for our color box, which is going to be the average color, as sum of image divided by square root. Oh no, what? 10 by 10. So it should just be length of a, I believe, if I can spell length correctly. That's what I want. Length of image. Okay, that should be fine. Okay, so now the next thing we need is the set of neighbors. Right now there is no set of neighbors, so it's just going to be an empty vector. And then we need extents, which is going to be from 0.0 to 1.0. Oh man, this is going to suck, isn't it? 0.0 to 1.0. And then again 0.0. 1 second. To 1.0. Okay, that does not fit on that line. I'm gonna move it to the next line because you know how it is. Okay, that should be fine. I'm also gonna do one more thing, which I forgot to define in our color box above, which was that we do need not only a set of neighbors but also a set of children, which is gonna be vector of color box. Okay. Well, let's see if I can do that correctly. Okay. Done it. Yeah, it's cool. It's cool. I mean, by the way, Ocelot, thank you so much for following. Really appreciate it. Okay. So there's going to be no neighbors, and there is going to be... Do we need neighbors? I think, honestly, we just need children, and maybe a parent, but I think we just need children. So let's just destroy these guys, and just say we only have children for now. I don't know, just making stuff up, which means I can put it all in one line. There you go. Progress. D $sign. Actually, I can't, I don't think. And I just screwed up big time because I pressed the wrong key. So now I have to write all that over again. So let's do that, shall we? 0, 0.0, screw it, I'm going to do it this is the easy way. 0, 0.0, comma, 1.0, and there. And now I'm just going to do dot and dot again. Yeah, so that still doesn't fit on one line. I don't know why I thought it would. But that's okay. We'll just move down to the next line. And that was a waste of, maybe a minute. It's okay. There, and this should be, right. So that should be our initial box. And so now what we have to do is we need to basically divide the octree up. Now the question is, how many levels do we have to divide the octree into? I suppose what we need to do is we could, okay, what language is this? This is Julia. The Julia programming language is what we're doing. Now what we could do is we could say that we just keep creating more and more like octree values until, so in principle, what you do with this is you continually split up your image again and again. So you split this guy up and this guy up and then that guy up again and then this guy up and then this guy up until every single pixel has its own box. Like that's in principle how you make the octree. In practice, we're only going to need to go down a level depth of like 1 or 2. In fact, only 1 for Quiltify, because for Quiltify, you really don't have too many options here. You either have 8 colors, or you have 8 cubed colors, which is 256, I believe. So there's no way you're going to have 256 fabrics. So I kind of feel like for the purposes of this particular discussion, we can have one big box with one big mean color. And then we can have 8 smaller boxes with 8 smaller mean colors, because I think 8 is a limit. I don't think we can. We might be able to go a bit deeper, but then we have to kind of question like which boxes we keep and all this kind of stuff. So I feel like we should make this kind of general, but it doesn't have to be that general. Okay, so make octree is going to take the image, and I'm gonna create. You guys are gonna hate me for this. I can feel the hatred already coming from chat here. But we're gonna say function, and I'm gonna create a new function, which is divide octree. Ho ho! I'm sure you see all this one coming, and we're gonna read in some sort of box. It's gonna be our color box. All right, and here we're gonna end the function. And basically all this is going to do is it's going to take the extents and it's going to make it smaller. Now, one other thing that I have to do here is I need to find some way to read in a level, which I guess I'm going to read in as a pointer. And we're just going to say that if level is, yeah, okay. I think I understand how we're going to do this. It's going to be kind of a pain, but I think I understand how we're going to do this. So in here, we're going to say, now we're going to do divide octree. Divide octree, and this is going to take in the box that we have created there, and then it's going to take in an array that's just 1. And in here, we're going to say this is a vector. Now you might be asking, why are we using a vector? Under what situation would you actually want to use a vector here? The truth is, the reason we're using a vector is because a vector is a pointer, and this way, as we're going further and further down, we I don't think we need a pointer. I was thinking about breadth first search, but for depth first search, we can just go down and we say if level is equal to, yeah, this can just be an int. I was way overthinking that. Ha! Look at me being dumb. Okay. I had to change like 50 references, but I did it. Dude, good job. This is the benefit of making big structural changes early. Otherwise, I'd have to change several hundred manually or trust an automated tool not to break the code. Yeah, I hear you. I mean, there's search and replace functions, but still, like, it's kind of a pain. Okay, so dividing the octree, what are we going to do? We are going to say, every octree is going to be divided 8 times. So we're going to say for I equals 1 to 8. It's octree, so it has to be divided 8 times. Okay, so we're dividing it 8 times. We're going to say the new child is going to... Ooh. This is ugly, isn't it? I want to write this with 3 for loops. So how about we do this the dumb way? Oh no, what just happened there? Okay. Can't say a child is ugly. I'm sorry, you're right. I can't say that. Hey, now using MPV. Oh, how's it going? So actually, it always takes me a second to get IRSSI working on my computer, but I do really like the flow. Like it's super nice. Incidentally, ever since I learned that you can use MPV for Twitch, which was honestly just a few weeks ago, or maybe it was last week, but this past week, I've done a lot of watching of Twitch specifically through MPV, and it's super nice. I'm a big fan of it. WeChat is more modern IRSSI replacement. Yeah, I know everyone's been saying I should, get on WeChat, but I have not used my Wii in a long time. Like I played Wii Fit a few months ago, but that was like the last time, so less RAM. Is it actually using less RAM? That's kind of surprising, but also maybe not too surprising. I'm not really sure. Okay. So, I'm sorry, I'm dumb. Okay. So what are we going to do here? We're going to say, oh, I really got to think about this because I suck at this. We're going to have to create 8 child boxes. So let's go up here and say children is going to be equal to a vector of... Can I do vector of color box? And then set this as undefined? Am I allowed to do that? Not really sure. Let's go over here and let's do using Quiltify. We're going to take a second to recompile images. I don't even really know if I need images here. And level here should be an int. Okay, no method matching colon type of... Oh, that's because I misdid this. Quiltify. Let's see. Use a suckless IRC client. Okay. What is your problem? No method matching colon. This is on line quantize 1. Let's see. Where T. No method matching colon type of color types color. Color types.rgb. Is this because I'm not using images before? Let's see what happens. Could be a scoping issue. I just find that a bit weird. Why not use Netcat? I didn't even know why they had an IRC. I didn't even know they had an IRC client. Netcat? I don't know anything about Netcat, so I can't really help with that. Method error, no method matching, colon, type of color types.color. Type color types. Is color already existing? Oh. Let me modify that. So it says CLR. Could just be a scoping issue. Okay, it was just a scoping issue. Color was already defined in images. So CLR not defined. Okay. Different error than before. That's okay. In expression starting at line 3. Well, of course, CLR is not defined because let's go here, Control D. Let's try this again. Using Quiltify. I don't know. I probably should have done using revise first, which I didn't do. CLR not defined on quantize 3. Right. Okay. Thank you. I'm sorry, I'm dumb. Let's see. Netcat is in lighter weight telnet. I just started using ST and I love it. ST, oh, the suckless terminal. Yeah, I tried using that for a bit, but I couldn't quite use it for what I needed to. So I ended up not using it for everything. So let me see if I can create this vector of color box of undefined values. And let's see what we can do. Actually, how do we normally do that? Vector of int, and we're going to say undef 10. So we're allowed to do that. So I want to try doing undef, and we're going to say 8, because there will definitely be 8 children. Okay? So now we're going to try the same with color box. Color box. Okay, maybe I have to do quiltify dot color box. Quiltify dot color box. It does exist. So no method matching array int 64.1. Type quiltify color box int 64. Closest candidates are undefined initializer. Well, okay, but what we can do is we can just say, how about these are all of the previous color box? So these are all type box. Okay. Will that work? So let's go ahead and define our box here. It's going to be equal to this. Just to make sure this actually runs. There should work. Image not defined. That is because I don't have an image. So let's just call all of these guys. Just for now, the color is just going to be 0. Maybe I can just do 0. Color box not defined. Oh, that's because it needs to be quiltify.colorbox. Okay, so that works just fine. So now let's try this call here to creating the children of vector box. See what that does. Again, I have to do quiltify.colorbox. Okay, no method matching array quiltify colorbox 1. Okay, so how do I do that? Let me see. I use Arch, by the way, just started. Cool. Did you mention that yesterday? Let's see. Debian master race. Fair enough. I have massive respect. I just went Serpent OS already. Oh yeah, I haven't seen Serpent in a while on Twitch. And Simula's opinion about distros is wrong as such doesn't count. Wait, what do you mean? My opinion on distros is that distros don't matter. Is that the wrong opinion to have? I feel like that's a fine opinion to have, isn't it? Okay. So if we do vector of color box, can I not just do a vector of? Yeah, that's fine. So why can't I do box? Oh. Maybe I have to do the following. Box for I equals 1 to 8. Oh man, that's so Pythonic. I hate it so much, but that's what we're gonna do. And we're just gonna deal with it. $, box for I equals 1 to 8. Meh. Initializing. Child boxes as parent box. Okay. So divide octree is going to take some sort of level, and in here, the first thing we're actually going to do is say if level, if level is equals, well, we'll say greater than or equal to max level. This is already getting ugly. Then we just return. Something like that. So that means this also needs to take into max level. That's ugly. But that's okay. You know, we'll make it prettier later. So the max level here we're gonna say is 3. Why not? What do we have here? Yes, I did mention that yesterday. Yeah, cool. I just like Pac-Man and the AUR. No, you think System D is the best thing since sliced bread? As such, your opinion is automatically wrong? I never said that. In fact, I said the opposite of that. Peepo Fat for real, thank you so much for following a few minutes ago. Sorry, I missed that. I said that System D drove me through loops. Like, System B frustrated me when it came out, but that was like 5-10 years ago, you know? Like, it's been a long time. Okay, and now this is going to be creating new accents. and mean for each child box. Let's see. Windows is the best distro though. That's an opinion. Mac distro. Nixie though they switched to glibc, I'm not surprised. Muscle is great in theory, really not in practice. Okay, what I'm gonna do. See, it no longer frustrates him because he loves it. Therefore, his opinion is wrong. Ah, my word. Okay, I'm gonna be right back, guys. Just give me a minute, and then I'll be back. Sorry about that. Yeah. So I'll be back in just a second. Okay, back. Give me just a second. Have I was not doing that. I'm sorry about that. The bot always comments right as things right, the right thing at the right time. That's fair. Is Moss System D? I don't know what Moss is. Sorry, I just did a weird thing to the microphone with my. Oh, hello, me. Okay, so I think everything's good to go. Great. So we'll keep going now. So again, the idea here is we have some large box that encompasses all of the colors of the image, and now what we're going to do is we're going to go and we're going to subdivide that box. So the new extents. I have to think about how to do this. The new extents is going to be equal to, actually, I think we just define this on child. So we can do chill, I guess we're going to do index is going to be equal to, this is a pain, isn't it? The index that we're going through is going to be equal to I plus 2 times j plus 4 times k. Probably works just fine. I don't remember what's the fast index and which is the slow index. Probably k is the fast index. So let's do this. That stays there, and this stays slow index. That's my guess. Serpent, not actually sure. What is serpent, by the way? I feel like you've mentioned it twice in chat today, and I feel like I maybe misunderstood what serpent was. For some reason, I thought it was related to Serpent AI, which is a streamer here on Twitch. But I've now kind of started to realize that that might not be the case. So let's see. Okay. So we have the index, and so this is going to be the index of the 8 elements, and it should just go 1 to 8, I believe. In fact, let's just. I feel like we should just do print line index just to be sure. I'm sorry about this, guys. Let's do Control D, Julia using revise, and then using quiltify. Okay, and then we're just going to run this divide octree thing and see what happens. Serpent OS is a modern, highly opinionated Linux distro. Is it? But if it's Linux, then okay. If it's Linux, then I understand why people are opinionated about it. Okay, so what we're gonna do is we're gonna do box is gonna be equal to this guy, and now we should be able to do divide octree on box 1 1. Divide octree, I guess quiltify dot. If level is 2. 7, 8, 9, 10, 11, 12. What? 13 point, thanks. Why isn't it outputting 1 to 8? Why is it outputting 7, 8, 9, 10, 11, 12? If level is greater than max level, for I is equal to 1 to 2, so if k is 1, oh, because we're all off by 1 indexing. For Pete's sake, why? Every time. Every single time. Okay, that should do it. Thanks, by the way, Alexor. I always screw up there. So there's 1 to 8. This is why I always have to check this stuff, because quite frankly, I just... I always get... Off by 1 always gets me. Always gets me. Okay. So, Supernos, let's see, made by EK Doherty, ex-Solus dev. Creator dev cannot remember what it is he was. What is... Okay, dumb question here. What is Solus? I should know. Adds 2 to Simuleos. Appreciate that. Thanks for that. Admittedly, though, I don't know what adding 2 means in this context. Okay. Off by 1 shall no longer be an issue. It will definitely be an issue. Okay. So we have the new index, and so this is going to go through all the children. So we're going to say children of the index that we are here. And just because I'm going to forget later, down here I want to say that box.children is going to be equal to children. So just to redefine it, just to make sure that we're safe there. Should be fine if we do it this way. Yeah, that should still be fine. I think. I mean, I guess if they're pointers, it's not that big of a deal. So maybe I should define them all as children up here. And then we kind of, change their extents. So now we want to say dot extents is going to be equal to... okay, so I've got to think about this. So we've got an R, a G, and a B channel. So we have R... and then I'm just going to open up a new line and bring it down here. G, and then finally a B channel. Okay, and then I forgot a comma in here. Okay, so what is this going to do? So we have the original extents of the box, right? So this should be the box dot extents of 1. So again, the extents of the box above it. So that's going to be R, and I guess we're going to have to do 1 again for the first element. So that's going to be the left element. So if we wanted the same as before, it'd be box.extents of 1, 2. Okay, but that's not exactly what we're looking for here, because so, like, for example, we take the red value, we split it into 2. So now we want it to go from 0.5. So it goes from the previous extents to plus box extents. I think, okay, let me just write something and see if this makes sense. This is one of those things that might be better. Oh, sorry about that, I hit the microphone. Solus is a series of electronic songs created by Exile Lord to serve as a very difficult custom Guitar Hero songs. Interesting. Okay, so now we're going to go here and we're going to say plus. Ooh, this is going to be a pain, isn't it? Box.extents of... I kind of want to do a new function that's finding bounds. Box.extents of 1, 1. You know what? Let's do that. Let's create a new function in here that just finds bounds. Function find extents. Extents. And it just reads in previous extents. All right. End here. It's literally, we just have to do... and then I think also what we want here is some sort of integer, which we're going to say is some sort of index I, which is going to be an integer in here. Okay. So I can either be 1 or 2. It can only be 1 or 2. I know this is a really dumb way to do this, but we know that I can only be one of those 2 values. So what we're going to do is we're going to say return if I is equal to 1. else if I is equal to 2, else, and print line, we'll say error, index, I, not found for box creation. Something like that should be fine. Okay, so if it's equal to 1, then we're going to do return. And what are we returning here? We need to return previous extents. So if it's equal to 1, then it's just going to be previous extents of 1, which is going to be on the one on the left side. And then it should be previous extents of 1 plus, and then it should just be the average of can I do a sum of a tuple? So what do we do? 1, 2. Sum of 1, 2. Is this allowed? Divided by 2. So what if I do plus sum of previous extents divided by 2? Okay, that'll do. I think I missed something. Oh, no, I did this right. Yep, that's right. So yank, and then we're going to paste this down here. And so now it's going to be this guy to previous extents of 2. That should be fine. So down here we're going to say, oh man, this is kind of rough, isn't it? dt comma, do that again. And now we're just going to say find extents. Okay, so now we've got to figure out. So if it goes from, so we're going to do 2 boxes in R, 2 boxes in B, and 2 boxes in G, right? Oh, so this should be easy. It's going to be find extents of box dot extents, and then we need the iterator, and this will be I for red. Gotcha. I understand now. And then we're going to do find extents and J for blue, or J for green, or something like that. And then finally we do K for green. Okay, so this should do it, I think. We're going to have to check that. Yeah, we're going to have to check that. I think we can try that right now. Yeah, so let's go ahead and try it. So if I do quiltify.divide octree box 1, 2, immutable, right? So I need to change this to mutable. Right, change this, go over here, Control D, try this the whole thing again using revise. And then after that, we're going to do using quiltify. There we go, perfect. And then we go from there. I did it. What did you do, Trash Talk? CVC proposes Simulos should cover his mic with stinging nettles so he will learn to stop hitting the mic rather than apologizing for it each time. The problem is, okay, the mic is on a boom arm. All right, welcome to Simuleo's art. So journal, new page before. Here is my computer, right? And here's the table that my computer sits on. And here's my keyboard, right? Here's my microphone. It's attached over here, and it goes up. Let me color it in a different color. It goes up, and then it goes up, and then it goes down, and then my microphone sits here. So that's my mic. So to type, my hands, here are my little hands, need to go here and here. So here I am. So what ends up happening is I keep accidentally hitting this part of the microphone right over here because my hand goes from up here and then I have to slip it under the microphone to talk, right? So that's the issue. Let's see. Another GitHub fan though, always fun to see. I watched Frost's AGDQ thing live. It was incredible. I did it. 666. Oh, nice. Good job. Next milestone will be 69420. Okay, interesting. Want to have the mic sit over your screen? Surely it should pick up enough. No, 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 it won't pick up enough. And in fact, it barely picks up enough now. So I'm using a SM58, which is it's first of all cardioid, right? So that means here's your microphone, and it has a sound level that kind of goes up like this, and it tapers off exponentially as it goes farther off. And the other issue is that it is it's an old school mic. I don't know how to explain this, but it's a different type of mic that picks up less background noise than the like for example the Blue Yeti or something like that. What's the dynamic? Is a dynamic microphone. Dynamic mic. Okay, this means that in order to use the mic, I have to use some sort of phantom power. Phantom power. And unfortunately, I don't have phantom power. So basically, this means that the range in which this can pick up sound is very small. So it's nice because it exponentially decays off, and it means that you can't hear background noise too much. But it's not nice because it means that the mic has to be particularly close to my face in order for it to pick up any sound. So if it was on top of my, if it was up here, for example, here's the microphone, that wouldn't work out very well. Dynamic mics are super common, but they are less common for streamers. They're more common for like singers and performers or things like that, where you usually have a large sound studio or something like that. Like the mic's not only from the vocalist, but also from the guitarist and all other stuff goes to the same sound system. So they have a lot of phantom power available for the system. Whereas in my case, for some reason, I just decided to go with a dynamic mic. I know why I went with the dynamic mic at the time. It's because I had a lot of background noise in my previous place. And so I went with the dynamic mic because of that, and it's fine. I had to pay double for it, and quite frankly, it gives the same quality as if I were to have bought a Blue Yeti, but whatever. It is what it is. I always use dynamic mics, and I have a roommate right behind me. Yeah, that's exactly the same here. It is very common. It's just that usually streamers go for like Blue Yeti or something that you just plug and play. You don't need that additional I have a Scarlett Solo, something like that. It's just an additional box that this then plugs into. So this plugs in there, and then that plugs back into my PC, which is down here. Right. I got the Blue Yeti for like $70 because previous owner couldn't figure out how to replace the USB cable on it. It has a user replaceable cable. Interesting. The same thing happened with my tablet not so long ago. I just like it broke, and by broke I mean I couldn't figure out how to, like the cable stopped working, and so I just bought a new USB like B cable. It was like an old school one. Okay, so we have divide octree now. So let's create our box, and now we're gonna do divide octree box, and I think I have to do quiltify dot, and we change this to 2. Okay. Matching plus for tuple float. Okay, so it does not like the plus operator here. So let me mess with that find extents function. So we're gonna do quiltify dot find extents. Does that not exist? Should exist. Find. Misspelled quiltify. Find extents. So now we're going to read in a tuple as just 1, 2, and we're going to do 1 here, and this works. It doesn't work. It actually provides the wrong extents. So it should be previous extents 1, and this should be minus. Sorry about that. That's the issue. And then down here, this should be that should be correct. No, wait, what? It goes from 1. Oh, it goes from 1 to 2, right? So the new extent should be from 1 to 1.5. And this guy goes... Wait, will it always be? No, I think this is just this. Ah, okay. And then this should be that. I think I just had it wrong. So I think this should find the right extents, which is good. I just had it wrong. Consider microphone is condenser microphone. Thank you. I appreciate that. I just had completely forgotten. It's been a long time since I looked at this type of stuff. Okay, so that found extents just fine. It didn't like the plus sign somewhere. Now, where didn't it like that plus sign? It didn't like adding a tuple, which is fair enough. You can't do that. But where was that? That was on line 34. Here. So the children.extents is equal to find extents should return a tuple. Box.extent. Aha. I understand now. Box.extents of 1, 2, and 3. Okay, so let's try it one more time with divide octree. Okay, so now let's say box 2 is equal to this. Now let's do box 2. I didn't return anything from this function, so let's go ahead and return that. Return box. And so what this should do is equal to quiltify. Okay, so this returns color box, which takes RGB 000. It's fine. Then it takes quiltify.colorbox. Let's do box 2 dot children. Okay, this is an 8-element array, all filled with color boxes. Great. So now we have our 8 children. Let's make sure those extents are correct. So the extents here are going to be... how did I define my original box? I defined my original box as going from 0 to 1. So all the extents here should be from... That seems wrong. The extent here is going from 0.05 to 0.05, 0.199 to 2, 0.333 to 0.333. Let's just... I'm sorry, I keep hitting the microphone and I'm so sorry. Gotta go, it's nearly 1 a.m. Thanks for the stream. Thanks so much for coming in. Have a wonderful evening. Get some sleep. Okay, so now let's just do box.extents of 1. Box is equal to that. Box.extents of 1. Interesting. Okay, so now let's just define box 2 again, dot children. Find box 2 again. Sorry about that. Over here is equal to quiltify, and now let's look for box 2 dot children of 1 dot extents of 1. Yeah, that is wrong. Whatever just happened there. But now let's look at box dot extents of 1. Yeah, so for some reason we're modifying the box's extents, which we shouldn't be doing. So we're saying box.children is equal to children. Okay, I think I understand what's happening here. Okay. I need to do copy of box here. And then I think that'll work. Box is equal to that. Now we're going to say box 2 is equal to quiltify. No method mentioned copy of quiltify color box. Okay. Let's just initialize a blank color box. Let's just do it that way. So we're going to do color box. And we're just going to say it's going to be white. So it's going to be 0. And then the how about we just do 0 blank vector 0 or something like that. And now we're going to do box 2 is equal to quiltify. Color box not defined. Does it have to be quiltify dot? No, that doesn't make any sense, does it? Color box. Oh, I mistyped it. Go here to big C. Go here to big D. Write this. Go over here. Box 2. Okay, so now let's do box. Sorry, box 2 dot children of 1 dot extents of 1. As 0 to 0.5 and extents of 2 should be. Oh no, of 1 1 should be 0.0. Wait a minute. Let's do extents of children. Extents of to, let's just do children. Let's see what happens here. So 1 goes from 0.5, 0.5, 0.5. That's correct. 0.5, 0.05. Okay, then 0.5 to 1. Okay, this is correct. The last one goes from 0.5, 0.5, 0.5, all the way up to 1. Good, so we do have all the right boxes. We have all the right children being created. We can keep going down this rabbit hole, but I think this is enough for now because this is all we really need for the color quantization. So now what we have to do is bin the pixels into each box. Now, here's where things get really annoying. I feel like, in principle, I'm going to create a stupid bin function in here. It's going to be a very stupid bin function. So we're going to say function, naive bin. All right, and in here we're just going to take the image, and we're going to take the box. Let's see. I finished coding the Simon Says solver, having resolved to the program design difficulties I encountered trying. Now to test it. Oh, good luck. Yeah, I'm excited to hear that. Let's go here to end, and let's type function correctly because I am bad at life. There we go. So function naive bin. What we're going to do is we're going to go through every single pixel in the image and just ask, are you a part of this bin or not? Like, are you in this box? Are you not in this box? That's all we're going to do. So we're going to say 4 pixel in image. And all we're looking for here, I think all we're looking for here is, I think for now, all we're looking for here is a set of colors. So in here, I'm going to say this is the naive, inefficient function to determine which colors are available, determine quantizable colors. And then in the end, when we do the converting to quixels or whatever, we're going to have to also figure out which color that we've decided are going to be the closest. So 4 pixel in image. What are we going to do here? We're going to say 4 pixel in image. We are going to end here, and we're just going to say if pixel let's see. I'm going to create another function here. I'm sorry, I'm writing. These functions are weird right now. Function, in box, and we're going to take in a pixel, and we're going to take in a box. Well, maybe we take in the extents of the box. No, we'll take in the full box. Why not? And here, so if in box, pixel, box, and here, all we're going to say is count plus equals 1. And we're also going to say box.color is going to be plus equals. Can we do this? Can we add colors in this way? Plus, come on, plus equals pixel. Okay, so let's see, can we add RGB colors? So let's do RGB of 0, 0, 0 plus RGB of 1, 1, 1. What does that do? Using images? Wait, what? How is RGB not defined? RGB? B? What? Using images? No, I must have images used. How do we... Okay, 1 second. RGB must be defined. It's a type, right? So I thought other color systems were much more popular than color arithmetic. Maybe. What other color systems are you talking about? So in your simulators, there's a U in color. Sure, there's a U in color, but also like, oh, HSV. Yeah, HSV is also probably more popular in some ways. We talked about the differences between HSVs and stuff like that in the domain coloring video, actually. Okay, so we're gonna do. How does RGB not exist? Maybe images. What? Using images. Now we do RG. Okay, I don't understand. Whatever, doesn't matter. That works just fine. Can we keep doing that? So what if this is like 100, 100, 100? Does that work? No, it does not work because they only go up to 255 by 255. So do I need to find a way to average these guys as they come along? Or can you do that? How would you do that? So okay, so I think what you need to do then is you need to say, can we do RGB of... Okay, I need to think about this. So we have some sort of color value that here they only go from 0 to 1. But what we want, I wanted to just add up all the colors and then just divide that by the total count in the end. But that doesn't seem like that's something we can do. So I guess we could have like a separate red value or something like that. And I'm not really sure. I need to think about it. Okay, but we'll do the counting and then we'll determine whether it's in the box or not. So let's do this. So we're going to add the count plus 1. I wanted to just say box.color is plus equal to color, but that's not going to plus equal to pixel color. So can we average it as we go along? We're going to do are we allowed to do... Okay, let me just try something over here. Let me try RGB of 0.5, 0.5, 0.5, and we're going to multiply that by 4. Oh, that works. But if I do plus RGB of 111, that works. 100. 100.0? Oh, it just has to be floats. We just have to make sure that they're casted onto floats, which is fine. They should be, I would imagine. I think. So in that case, it's probably fine. Okay, so then I was just really overthinking it. So we'll have box.color, and then at the end here, we just have to do box.color is going to be divided by count. And then we have to define count as equal to 0 up here. Something like that should do. Okay, so now we have the divide octree. No, the next thing I need to define the inbox function. And here, basically, we have the box, we have the pixel. All we have to say is, I keep hitting the microphone and doing dumb things, and I'm sorry about that. So here, what we're going to say is, if really got to think about this. If we have the extents, so I think if pixel dot r is greater than a box dot extents of 1, 1, and pixel dot r is less than box dot extents of 1, 2, and we're just going to do this for G and B, and this is a dumb way to do it, but you know, whatever. I also missed an ampersand at the end there. Yeah, okay, this is dumb, but you know, it should work. G, B, B, G, and this should be 2, 3, and then 3 and 2 up here. 2. And then we're just going to return true. Else return false. End. All right, cool. Something like that. So basically we're saying if we're within the red bounds, within the blue bounds, green bounds, and within the blue bounds, then we return true. Otherwise, we return false. Okay, cool. So now we should have the ability to naively bin. Um, Again, it goes through every single pixel in the image, so it's really stupid. But, you know, whatever. So we're going to say children dot of index. Naive bin takes the box. So I feel like what I should be doing is I should be returning a color from here. But I think I'm just going to do it this way. So I might just do, I might change that to this. And then down here, we might just do naive bin of this. And then we're going to do image, which we are not reading into divide octree. So we're going to have to read that into divide octree, which isn't great. And then children of index. Something like that should do. And now what we need to do is, give me a second. Julie is righteous. I don't know. It depends on definition of righteous. And so here we're going to read in the image. I kind of want to put the image on at the front just because I kind of want to do that. Okay. So now let's go ahead and define an image as equal to rand of RGB 10 by 10 or something. So now we have our image. The conditions themselves are the conditions themselves are expressions and can be used as return values, right? Return true and false seems redundant. The conditions themselves, if are, yeah, I suppose we could. I like explicitly saying return true and return false. Sorry, I'm kind of an old school programmer. I just, if you can make code easier to read, I feel like you should just make it easier to read. And I feel like this is easier to read than, you know, not doing that. So it's kind of like, I agree, it's like a micro optimization and no one really cares, or I don't really care. So like if people like argue about it, yeah, totally agree. Like just, you know, whatever. But okay, so we should now be able to create a bunch of children that have a bunch of different colors associated with it. So let's go here. We have quantize, make octree. So we should be able to make the octree on the image. We have divide octree here of the box. And I believe what I want to do is make this also a mutating function. So let's go here. Hey, Dave Bees, how are you? And go there. So now in principle, I should be able to make octree of image. Quiltify. Dot make octree. Misspelled quiltify. Try that one again. No mathematical divide octree exclamation mark on quiltify.colorbox. That's because it takes the image now. So let's grab that right here. Try it one more time. What's the issue? Image not defined. Image not defined. Image not defined. What does that mean? I must have accidentally used the word image, where I should have been using this. It made an octree. Okay, that's great. So now let me just look through all the children of this octree. So we're going to say tree is going to be equal to that. And now let's do tree dot children. Actually, let's just do tree dot CLR. And this gives us some sort of random float. Seems fine. So let's do tree dot children of 1 dot CLR. And this should be different than the other guy. Oh, also, this is clearly wrong because these values are above 3. Yeah, okay. This is clearly not quite right, but we're getting there, like one step at a time, slowly but surely. Gweppy, hey, how are you? Hope you're having a great day. So let's see. We're getting there. So the original color of the tree is fine. However, the color of the children is not quite right because these should be values between 0 and 1, but this is clearly, it's like 13. Like, how do you get 13? That's clearly not right. So something is wrong with the naive bin values. Yeah, the values should be below 1. So that's why clearly we're not quite there. But also, we were able to create a box, split it up into 8 smaller boxes, and create 8 children with RGB values associated with them. So we're getting there. It's just not quite there. The only other thing, a quilt. Yeah, so the idea here is that we want to take some sort of image. I think I drew a picture of this down here. Some sort of image, like let's say a tree or something like that. And we want to, first of all, color quantize the quilt so that we can figure out, you know, what are the minimal set of colors that are necessary to create recreate this image, right? And so we want basically 8 colors that could represent the image. And then after that, what we want to do, let's see, do I have a better image here? We want to cast that onto a quilt-like texture. So the idea is we need to create some sort of grid that allows for basically quarter squares. And that's going to be a bit tricky, but I think we have an idea of how to do that. And then after that, we're going to apply some sort of textures to it. And so you should be able to take any image and turn it into something that looks kind of like a quilt. And that's the idea. I want to be able to just read an image, put it through this quiltify function, and then after putting it through quiltify, we have basically an image that looks like the old image, just kind of like a quilt, so kind of cartoony in some ways or something. We'll see how it actually goes. I've got a feeling there's going to be a lot of tricks that we have to play to actually make it look cool. But the nice thing about this is it's kind of a mix of, at least it's kind of an application of the color quantization thing that we did before, like a long time ago. And it's kind of cool to reuse some old code for that kind of stuff. So right now we're at the color quantization step, which is probably the trickiest bit, but also I figure it was something that I figured we could knock out in a single stream. And then we'll come back tomorrow and we'll implement the other bits, which will be basically creating what we called quixels, which are like individual quilt pixels. And then after that, we need to find the applying of the textures and stuff like that. So we're very close to a final product here, because we have the ability to create. Basically, we have the ability to take our image, convert it into RGB space, and then quantize it so we can find all of the pixels that fit into different boxes and stuff like that. And then after that, we can basically create a set of. We're basically at the stage where we can create a set of colors that can adequately re-represent our image, and that's kind of where we're at right now. So we're working on that. So how is this? So this doesn't seem to be working as intended. So we have if pixel R and G. So if pixel R is greater than box extents 1. I don't understand how we are increasing beyond how we're increasing beyond 0 and 1 unless our box.color here is so our box.color starts as 0. It has to start as 0 because we've initialized at 0, right? So children of index starts at 0 in color, right? So what we're doing here is we're adding 1 to the count, and then we're adding the colors of whatever pixel we're on to the pixel, right? So that means we should have the count of how many pixels we have, and then we should have all the pixels added up together. And then if we divide that box.color by the total count that we added up, I don't understand how that could be greater than 1. So let me just really quickly, I'm going to go up here and we're going to do print line. Well, actually, let's just do it down here. Print line, and we're going to do box.color. Right, this, go over here, and now we're going to try tree is equal to quiltify again. And right, so it looks like, it does look like at that stage we're already going wrong. Cool. Okay, so that's good. The question is, how exactly is that wrong? I'm going to do something dumb here, and we're going to output the color of each pixel. So print line pixel, and we're going to write that. And also I'm going to add in a new line after this. Well, let's add the new line later. Down here. Tree is equal to quiltify. Okay, so what do we have here? We have, it looks like all the pixel values are between 0 and 1. Ignore the top one of each column. This one's not correct. So how about we try something else then? We are also going to do a print line after this. And then up here, we're going to do print line box.color. See what that does. So now we're going to do tree is equal quiltify. And yeah, all these guys start with a 0, 0, 0. So then we add up all of these pixels together. So 0.8, all these guys added together. I feel like all these guys added together are going to be I feel like the division just didn't do anything. Let's see really quick. So we're going to print line box.color before and after. Yes. And yeah, the division did nothing. So is that because this is an integer value and I need to change that to a double value? No, I don't understand. Oh, I'm dumb. I'm so dumb. There we go, perfect. Good thing that wasn't live on Twitch or anything, so no one saw that. All right, let's do DD here, DD there, perfect. Okay. Okay, so now we do have a set of colors that I think does adequately represent the colors we have in our image, I think, to some extent. So now the next question we need to do, there's a couple things that we have to think about here. You just have bad luck while thinking. Oh no, that makes it even worse somehow. So in here we're gonna say to do quantize quantization may fail if no colors of particular no colors of associated, no colors for a box. I mean, it's clear that that might happen, but you know, just to make sure. So for quantized image, we're going to say the boxes are going to be equal to make octree. Well, let's call it tree just to keep it. So tree is going to be equal to make octree here. And now we need one more function in here, which is going to be function, and it will be find color set or something like that. And this will take in the tree, and basically it's just going to return. It's going to go through the tree, and it's just going to find all the colors. And then we need a few more functions in here, which is going to be function color distance. And then down here, color distance is going to read in some color 1 and color 2, and here. And then after that, we need a final function that actually does a quantization. And all it's going to do is it's going to transform any pixel in the image. And so we're going to say, yeah, that's going to be this quantize function in here. So in here, what we're going to say is if we expect you to implement everything blindfolded right from the first try. Look, we already did a blindfolded programming challenge. You saw how that worked. I don't know. I'm still 50-50 on whether I turned that into an actual YouTube video. Like, I quite liked the challenge and it was a lot of fun, but also like, I don't know. It didn't quite, it was hard to make into a video. Okay. So tree is going to be equal to make octree. Down here, we're going to say color set. It's going to be equal to find color set. And then down here, we're going to say color distance on color 1. Wait, I need to think about this. So we do color distance on color 1, color 2. So 4 pixel in image. And here, we need to find the color distance from all of the color sets. So basically, we have 8 different colors. Find color set in here. 1 second. So we want find color set, and this is going to read in the tree, and then the number of elements, which here we're going to say is 8. So tree, and the number of colors we want to return. So in this case, we'll have 8 colors. And what we want to do is we want to make it so we go through each, we iterate through each of the 8 colors, and we find the minimum. Distance. So we'll say distances. How are we going to do this? So we could do. We need to map. So we need to find the minimum distance. So let's just say distances is going to be equal to color distance. And I think I can just do this of color set. And then pixel. Right. And so that'll find our distances. And now we have to do find min. I'm going to have to work with this just a bit. So it's something like this. So we find the set of distances and we find the minimum distance. And then we say, we don't care about that, but we do care about minimum element is going to be equal to find min of distances. Something like this. And then we're just going to say pixel is going to be equal to color set of minimum element. Or something like this is what we're looking for. Again, it's kind of wishy-washy here as to how this works. And then I guess we're just going to do quantize here on the image itself. Or maybe we don't. Maybe we create a... Maybe we say image out is going to be equal to copy of image or something. And then we're going to do image out here. And then we're going to say pixel is going to equal to that. And then finally down here, we're going to say return image out or something. Okay, so to find the color set, what are we going to do? So this is going to be the set of colors that we can use in our quantized image. And to find the color set, we're going to have a tree. It doesn't have to be 8. This is going to be color number, the number of colors that we want in the end. Okay, so we have finding of the color set. And then we have the color distance, which is also fine. In fact, the color distance is a bit easier. Let's just do that one first. So this will just be return square root, and we'll just do an L2 norm of color 1.r plus color 1.r. Again, we could do an L1 norm or something like that if we wanted to, but it's probably okay. Squared plus, I'm just going to add this down to the next line, I feel like. And we're just going to do the following. And then we're going to do this. And then we're going to do that. And then finally, we're going to change this to G and G and B down here as well. Okay, I accidentally deleted a line. So now the last thing we need to do is find the color set. And in principle, this should work. It probably won't because I just coded a bunch of stuff and it's probably all going to fail, but that's okay. So finding the color set. What we're going to do is we're going to iterate through all children. I feel like for the first iteration here, what I want to do is for the first iteration here, what I want to do is just, let's see. I guess we can say, okay, so we're going to have the color set. So we're going to say color set is going to be equal to 0 for RGB of 0 for I equals 1 to 8 or something. I don't like this implementation already. Can we do... Oh, I guess we're going to say the following. Now, should we apply... Yeah, okay, let's do the following. So we're going to do, for our color set, we're just going to keep going through all children. Yeah, we're just going to keep going through all children recursively. And we're just going to do it. So we're going to say, I called this something slightly different and I probably shouldn't have. So we're going to say tree. So we're going to say color set of the index is going to be equal to tree.clr. And then we're going to say, let's see, never saw you doing unit tests. Do you ever come back to extend your algorithms later? The answer is yes. I don't do unit tests so much on stream, but I do it for my work and stuff like that. And also, when you say I don't do unit tests, that's kind of a bit not true, right? Because every time I write a function, I do definitely test the function over in the REPL, right? So like, I don't, like, I'll test, right? And I definitely do tests in production code, but also like, usually what I'm doing on stream is for either a class or it's for it's something where you're trying to explain an algorithm, in which case I don't usually do the unit test there. But every algorithm in the algorithm archive has like a small test just to make sure it works. We should probably do better with testing though. That's a completely different story. So now we're going to say for child in tree.children. And actually, I'm going to modify this so it says box instead of tree. Just because I just, yeah, I'd been calling them boxes before, and now it's kind of weird that I'm not calling it boxes. So we're going to do here. Any other time I said tree. Next. Tree.color. Should be box.color. For child and tree.children. And here we're going to say, I think he doesn't need to test his code. He's a mathematician, so he's fine with the code theoretically working. Oh man, that one hurt. Is there an undefined for color? Okay. Can I do Control D, Julia, undef? Can I do array of RGB using images? Okay. So let's just see what I can do. So I think what I want to do when I initialize these guys is I want to see, can I do RGB of nothing? No, that didn't work. Let's try array of RGB of nothing 10, undefined 10. Okay, that seemed to work. So when we define these guys, let's define them as all undefs to begin with. So the color here is going to be, let's try nothing. And then also when we create the initial node, here, we're going to say the initial color is also going to be, oh, no, this is fine if we do it that way. Let's see if this still works. So now we're going to do using revise. And then after that, we're going to do using quiltify. Okay. Give it a second to precompile because it's doing a few, I think it's doing images in the background. And then once that's done, we should have, yeah, so we have quiltify built. So now I should be able to define a box here. Oh, actually, I should just be able to make octree. Quiltify dot make octree of image. Image not defined. I need to define image. Try it again. Quiltify. Right, so it does not like that. Cannot convert object of type nothing to object of RGB. Can we do undef? Is that going to work? It looks like it might be working. Perfect. No, it didn't work. Can't convert type of undefined initializer to type RGB. What I'm trying to do is create like an RGB value that is clearly wrong so that can I do, okay, let's just mess around a bit. So A is going to be equal to RGB of 0. So A dot R equal to missing. No, it doesn't let me do that. Let's see. Can I set it equal to -1 or something? No, that doesn't work. But maybe if I do 0.0 and then I set it to -1? No, that also doesn't. Wait, set field, immutable struct of type RGB. Can I do this? Nope. Okay, so that seems to work. We can just do something really, really stupid here. And just say we're setting this equal to a set of -1.0, -1.0, and then -1.0 or something. And then down here, when we're doing finding of the color set, the first thing we're going to say is if index is greater than or equal to color num, then we end here and we return. And then what we say is color set. The color set that we're working with is going to be equal to that. Maybe we need to do this in here. And then we do find color set on the color set. And then we read in the box, and then we read in the first iteration here or something. And so in here, we're going to do color set, box color num. And the last thing we need to do is, we need the index. Something like that. So then we're going to say if yep. So now we're going to say if color set, no, box.color is, if box.color sum of box.color divided by 3, I suppose, is greater than 0, greater than or equal to 0. 0 is still fine. End here. Otherwise, for child in this, we end here and we also do index plus equals 1. And I think I'm going to do index of 1 plus equals 1 here. The reason I want to do that is I think I actually want this to be an array so that it's like a pointer that's being passed around. So if index of 1, that way, like, if like some node all the way over there adds a color to the color box, we're fine. And in fact, we should probably make this be a breadth first search instead of a depth first search. Modify to be BFS instead of DFS. That's probably the best way to do things. So here we're going to do to do. I mean, BFS isn't so hard. We can do that, but for now, I think we're just going to keep going and not worry too much about it. And then in here, we're just going to say for child and tree.children, we're then going to do find color set of color set, box, index, and then color number. Okay, so in principle, this should work, but let's just see what happens if we do quantize, quiltify, dot quantize of image. This make octree has no field color. Make octree here. What does that actually take? It takes in just the image. Try it again. Can it convert object of type tuple float64 to an object of type RGB? Convert C. Where is this? This is going to be on line 52. So we say children.colorbox. I see. So it doesn't like... Right. So it doesn't like my casting onto negatives solution. Which is probably fair, because that's bad coding practice anyway. But, you know, like, I was hoping. Okay, so we have colorbox of... I really wish we could do... Let me modify this. So this doesn't just have to be an RGB. It can actually be a union of RGB and nothing. And then I'm going to set these all to be nothing. So let's do -1. And then in here, we're just going to say nothing to begin with. Hey, Anakim Luke, how are you? I'll answer that question in just a second. And then in here, we're going to say if box.color is not equal to nothing, then that might work. So let's try that. I might have to redo this again. So Julie _project using revise, and then using quiltify. And now after that, we're going to do 1 second. Give it just a second to build. And then we're going to try the, oh no, in union, expected type got value, nothing. I'm not allowed to do a union of RGB and nothing. Union of float64, nothing. Okay, so we need, probably type nothing with capital N. Yep. That was my bad. Break this, go over here. Try it one more time with Quiltify. Hopefully it precompiles, and then we can go from there. I'm happy that I added functionality to my program. I'm going to play some video games. Cool, have fun, man. So as far as making a quilt is concerned, the idea is that we take any image and we turn it into something that looks like it could be on a quilt. So the idea is we take the image, we first quantize the colors. So there's a finite set of colors and in principle finite set of fabrics that can be used. And then the next thing we do is we modify the image so it's kind of pixelated in a quilt way. So we use like quarter squares and stuff like that to determine like the final image. And so the idea is that we could take any image and then we could turn it into something that looks kind of weird and funky, and that's kind of the hope. We're looking for like a weird, like, I don't know how to put it, like a weird, quantize image. Oh, image, like quilt, like, I swear. So now we're gonna do image is equal to rand, and now we're gonna do quiltify quantize random image. Nothing not defined. What is a quilt? Really? Okay, I can, yeah, quilt. Quilt. It's like, images, like something like this. Here, so like, see how it's made of a bunch of squares? And if you look at this, sorry, our images are copyrighted. Okay. No, okay. Yep. I understand the copyright thing, but I just wanted to like show an example here. One second. So you can kind of see it here. So the point is that the quilt is made of a bunch of squares, which are then made up of a bunch of quarter squares and stuff like that. So the hope was that we could like draw an image, and it could be like basically a bunch of these like kind of quarter square type guys with all these little triangles and stuff like that. And we could like take any image and turn it into something that looks like this. So we have a set of patterns and a set of colors that we're allowed to use and stuff like that in the background. A no method matching plus for nothing RGB and float. This is going to be on line 39. So here a box.color plus equals pixel. And I guess here we're just going to say for pixel and image if inbox. I see. So for pixel and image if inbox. And I'm just going to do an additional thing in here. Say if box.clr is equal to nothing, and then we're going to change it to an RGB value. And here, and we're going to say box.color is equal to RGB of 0. We'll do 0.0 just to make sure. Let's do here quantize. Broadcast. Why would we need a broadcast? This is going to be on line 88. I think we're making progress. Color set index is equal to box.color. Probably we do need a dot equals there. Quantize RGB float. Can it convert RGB float 64 to, it's going to be on line 107, it looks like. We are getting there. Find color set is on line, and now it's on line 88. Okay, cool. So we're still on this line. Sorry, I was browsing Twitch, typing random topics, and ran into your stream. That's cool. I thought quilt was a coding term, but no, you're literally coding a quilt. Yeah, that's literally what we're doing. I just thought quilt was kind of a men's skirt. Oh, no, that's a, what is that called? What is that called? Kilt. You're right, not quilt. Thanks for that. Okay, so color set of index. No, I did want equals to box.color. So color set is going to be defined as RGB 0. Oh, I see what I need to do. Index of this is going to be dot equal to that. Try that. No, that's not right either. Box.color should be a color. If box.color is not equal to nothing, no, that should be right. Index should be a single value. So color set should be, oh, I see. We're getting there. What is the issue here? It says it's still on line 88. Interesting. So it's saying color set of index. let's just print line. Type of color set of index. And then we're going to do new tab. I'm not Googling for quilt. Why not? That's probably an interesting thing. There, here, write this, go over here, and now we're going to do that. And it says RGB, and then RGB of float 64. Okay. This is because this needs to be RGB of float 64. RGB of float 64 1, float 64. Interesting. Why is it not allowing us to? Well, what if we just do 0 0.0, 0 0.0, 0 0.0? Okay, maybe I do need a dot equals? But that seems weird to me. Let me just, oh, you're now, okay, fair enough. There probably is something like a quilt. That's probably a thing. So I'm gonna say A is gonna be equal to RGB of 0 0.0. Let's just do 0 0.0, should be fine. And B is gonna be equal to RGB of 1. And now we're gonna say A equals B, and that works. So is the issue, no, they're both float 64 RGB types. Interesting. So what if we say, okay, so let's try this. Color set is equal to this, right? So we're going to do that. Okay, so now we want to say color set of 1 is going to be equal to RGB of 0. That works. Yeah, that works just fine. So what's the issue? Index assignment with a single value to many locations is not supported. Perhaps. Okay, no, I do see the issue now. I totally understand it. Sorry. Here. Tree is not defined. It should be box. Try it again. Color set not defined. That's because I'm not using the underscore. So color set down there. Okay, we are getting there. Color set not defined. Did not write it. Color underscore set. Find color set, find color set, find color set, color set. Okay, did something. We returned a color set. Nice. Okay, and this should have actually returned an image. So what we're going to do is we're going to do image 2 is going to be equal to quiltify. Okay, that was not what I meant at all. Quiltify dot quantize of image. Okay, and we're going to say image minus image 3 is going to be equal to image dot minus image 2. Oh, they're all zeros. Crap. So we clearly did something wrong here. Return image out, find min distances, and we're going to say pixel is now the pixel and image out. Okay, we have to modify that a bit, but we are getting there. Guepe underscore, thank you so much for following. Really appreciate it. It'd be funny to kill image as source 3 algorithm testing. I don't really know. Is this going in the algorithm archive? Yeah, color quantization, yes. Color quilting, probably not. No. I was just really interested in this, and so color quantization, I'm definitely trying to put that in the algorithm archive because it's been a long time since we did this. But no, quilting will not be. What I'm trying to do now is I'm trying to do like applications of algorithms and put those in the on YouTube videos and stuff like that. And I think this is kind of a cool application to color quantization that I thought about recently. So I was like, hey, let's just do the full thing. Let's just go through, do an application of color quantization, do this whole quilting algorithm and stuff like that. Some algorithms in the archive don't have code. No, all algorithms in the algorithm archive have code. However, some of them might not have code in your preferred language. If there is not code for an algorithm in your preferred language, then yeah, you can definitely put a pull request up for that. I'd appreciate that. And some of them, like, we're working on it, like, slowly, but, like, I'm adding some stuff. Like, for example, the, um, structs and, the trees and stuff like that. Didn't see it for gift wrapping? Oh, it's totally there for gift wrapping. Um, algorithm archive. Admittedly, that was one of the early chapters, and I wasn't sure how to weave the code into. So if we go to gift wrapping, here for Jarvis March, and then also for Graham Scan, it's for both of these guys. Admittedly, it's not here for gift wrapping because the sub chapters of Jarvis March and Graham Scan are where you see the code. So, and also again, these chapters need to be like massively rewritten. Like I totally agree with that, and I'm sorry about that. I'm not quite there yet. So image out is going to be copy of image, and then we're going to say 4 pixel. So apparently I'm not able to. So let's just say for I. In image out, I will say length of image out, and then down here we're going to say image out of I, and then let's go down here and say image out of I. Okay, let's try this again. So we're going to say image 2 is equal to quiltify. Do it again. And now we're going to see image 3 is equal to that. It's still all zeros except for that last one. Let me do I am show I am nope. Where's I am show? Let's go into VI source and quiltify using images. Is it an image show? Using image view probably is what it is. 3D gift wrapping would look cool. Yeah, it looks super cool, but also it's super hard. That's why we didn't do it. So we're going to do using image view in here. Failed to revise quiltify. Run code doesn't match save volume for. Okay, that's fine. Oh, that's because I misspelled view. Yeah, okay. Yeah, so 3D gift wrapping is hard because you have to think about like the surfaces of 3D topological things. Like the truth is there's so many cool algorithms that I want to cover, but I can't because I don't have time. So I'm going to pause you to go to watch a video of yours. Oh, cool. Yeah, I appreciate that. But also, if you are interested in a video on color quantization, I think that might be my video if you're looking for that video. It's only got 10,000 views or 9,000 views or something like that. So it's not one of my like most viewed videos, but it's there. And I think it's a good video to watch. Sorry, we're just waiting on image view to precompile, so give us just a second. If you guys have any questions, comments, concerns, now's the time to say it. And now I think I have to do revise dot oh no, retry. Okay, so now I think I'm okay. So now we're going to say image 3 is going to be equal to that. So now if I do I am show of image 3, what do we get? I think this will work. Okay, so this looks pretty black. Oh, there's a single green dot down there in the corner. So let me try image show of image 1. Image. Okay, so this is our original image. Great. Okay. And here was our quantized image, which I think look identical because, except for the fact that our quantized image has for some reason a black dot down there. So we aren't quite there, but we're super close. I think if we just work on it just a little bit longer, we can get it working today. 240 dB, thank you so much for following, really appreciate it. Okay, so what is the issue here? It could be a number of different things. Let's just output here the min element, print line min element, because I might have gotten that wrong. So image 3, image 2 is equal to quantize, and it says 8. That seems fine. So for I in length image out, let's also print line, because it seems to have only gone through once. For I in length image out, let's print line. Interesting. I here, go there, and now we're going to do image 2 is equal to that. Why are we... For I in length... Oh. 1, 2 length of move image out. Try it again. Okay. That did something. Now it looks like we're all quantized to black now. Because it looks like all of our distances were closest to black. Okay, so that's interesting. But on the upside, we can definitely say now that our image is that we're going through all the pixels and we're turning them all black. So that's interesting. Let me see if I'm doing find min right. So we're gonna do A is gonna be equal to 1, 2, 3, 0, 1 or something. And now we're gonna do find min on A, and this is gonna be Cartesian index 1, 4. I think if these had commas, then it would be find min would just give you 4. And 0 is the lowest element. That seems fine to me. Correct. So 0 is the lowest value. Now, do I want... Okay, so we find the minimum distance. So we find all the distances. Let me print line distances. And let's add some tabs in here. Let's just mess around a bit. So we'll do a tab here, and then we'll do tab here, and then distances. Perfect. Like that. Go here to img2. What? Char has no field distances. Oh, that's because there's a period there. Okay, is this what I wanted? I can't really tell. How about we just do the sum of distances? I'm just trying to see if they're different. Okay, so we're going to do image2 quantize, and it looks to me like every single pixel in the image does have a different distance. So they are a different... So basically the idea here is we created the set of possible colors we can pull from. Then we went through every single pixel and we saw how far away they were from each of those possible colors. And then we tried to set the pixel equal to that color that it was, set it equal to that color. So this says to me that we might have, hey Anakin Luke, welcome back. So we might have done something wrong with this color distance function. So here what we're doing is we're saying we're doing the square root of color 1 plus color 2. Okay. So maybe it's in this color distance thing here. That could be right. How about we just say distances are going to be equal to the following. So this is really, again, Pythonic. I don't really like it for I equals 1 to 8 here. And we're going to say color set of I. And let's just see if that does anything. Image 2 is quiltify. That did something. And it looks like it did something well. Okay, good. Well, maybe not. Because actually, as I'm going up here, it looks like... that's because my eyes... So let's do J in here, and let's do J in here. Okay, quiltify again. This looks reasonable, except it's now choosing 8 all again. So this is the same thing as before. Would you like better, Python or Vim? Vim, no doubt. I think this is the same thing we just had before. If we do this, and then color distance of dot of color set... and then we delete here, right there. So let's try to comment that out, write this, and then we're going to say image 2 is equal to that. Oh no, those do they look different? So let me just look at those last 4. 13, 16, 12, 11. 13, 16, 12, no, they're about the same, I think. So let's just do this one down here because it's, slightly different. Okay, so now we have the minimum value and then the minimum element associated with that value. The minimum element for some reason is always 8. And that's weird to me. It shouldn't be always 8. And then we say image out of I is going to be equal to the color set using that minimum element, right? So the idea, again, we have a set of colors that we're choosing from. We find the distance of the color of the pixel with that set of colors. And then what we do is we say, okay, well, this particular pixel here is closest to this random blue color. So let's try to make it so that our color is now blue. Now 8 is apparently just black. It's just 0, 0, 0, which is also surprising for other reasons. So let me see what our color set actually is. So let's do print line color set here. And then let's do comment that out there, because maybe our color set is just all black for some reason. So we're going to do image 2 here, and our color set is definitely not all black. It's just the last element is black. So let me try printing out the pixel value. This is interesting. Okay. So we're doing the magnitude. I think, in fact, what we want isn't the magnitude here. So I was doing the magnitude of color 1 plus color 2. But I think we actually want some sort of difference notation here. I kind of just realized that. Because what we have here is we're going to have like two values in space. So we have like a value here, and then we have this guy, and then this guy, right? And what we're trying to see is which one's closer, A, B, or C, right? So we have some value here, there, and there, right? Well, how do you measure the value from B to C? These have some sort of XY location, X, Y. And so if you take, how do you find the distance? Am I just dumb here? The distance between, okay, so let's say the origin is like here or something like that. So that's our origin, 0, 0. Okay. So now we have C, which is somewhere up here, A, which is somewhere over there, and B, which is somewhere over there. So the distance between B and C, I'm just going to Google this because I'm dumb. Distance formula. And you guys are just, yeah, it is that. Coordinates of the first point and coordinates of the second point. Oh, it's minus. Of course it's minus. And because it's returning square root, will it always return? This should always be positive. Okay. Okay, so now we see a healthy spread of 1s and 8s. It's just 1 and 8. I was hoping it'd be something other than 1 and 8, but let's just try I am show of image 2. Meh. Oh, of course it's 1. Yeah, okay, I gotcha. So what I'm gonna do then is I'm gonna make it so when we find the color set, we ignore the first box, because the very first box has a color that's equal to the average of all of the colors, right? And so because of that, all of them are going to be incredibly close to 1, or incredibly close to that average, because it's an average of all the colors. So that's probably fine. Guepe, you want to install Julia now? Fair enough. It's a pretty cool language. So what I want to do here is I want to say the distances are going to be equal to the color set. And here I'm just going to ignore that first color. So let's go here and let's do 9, actually. And now we're going to do 2, 2, 9 or something. Write that. And now we're going to do image show 2. Attempt to access 8-element array with element type RGB at index 2 through 9. Color set of 2 through 9. Attempt to access 8-element array with element type. It should be more than find color set. Oh. Yeah, because I need to mount. Yep, something like that. Okay, do that again. Image 2 is quiltify. And now we're all 1s and 8s again. That's interesting. Okay, so let's do I'm show image 2. It is a different image, but now it's all the same color, which is definitely worse than what I was expecting to see. So, okay. We're getting there. Print line color set. Let's just see what we're printing here. So the color set here is fine. It looks like we're fine. I also realized here it has to be color set of min element like +1 or something. Right. And so now if we do I'm show of image 2. Yeah, so now this is the same image we had before. Okay, so why are we the color set's going from 2 to 9 now, so we're ignoring 0.1 to begin with. What is the difference between? Oh. Is that the case? Let's go up here and let's check the color set again. 53953. Okay, good. We are making progress here. Let's go back to this and that. And this. In fact, let's go here and say color num. And let's go down here and just say color num. And down here do color num. And then we're just gonna, yeah, I think everything else should be fine. So this will return back the same thing that we just had. No method between quantize. This has to be 8. Okay. So the issue here is that our find color set is returning the same value every time. So it's just returning 8 values that are the same color. So our color set is all the same color right now, which is not what we were hoping. So maybe we need to think about this a bit more. And let's create a new array here. So we're going to say image is going to be equal to, we're just going to say, how am I going to do this? I'm going to say RGB of 0.0 plus, and then I guess I'm going to do we need to iterate through all R, G, and B values is the idea. So I want to create like a smooth gradient of RGB. So I guess I'm going to have it so as you go up, it becomes red. So you start off green at the bottom, and then as you go up, it becomes more red. As you go left, it becomes... Okay, so here's what I'm going to try to do. I'm going to try to create an image that is green down here in the corner, and then as you go up, it becomes more red. As you go over here, it becomes more blue, and then as you go in either direction, it becomes less green. So that's what I'm going to try to do. So it's going to be 0.0 plus J over 100. And then it's going to be 0.0 plus I over 100. And then it's going to be the absolute value of 1.0 minus, and I guess I'm just going to do 1.0 minus, well, no, how about we just do it this way. It's going to be 1.0 minus I plus j divided by 50 or something like that, for I equals 1 to 100, j equals 1 to 100. Something like that, maybe? Okay, so now if we do I am show of image, we get, yeah, so we get some sort of weird gradient thing. I mean, again, this wasn't exactly what I was going for, but, you know, it is a weird gradient thing. So now we're going to do img2 is going to be equal to quiltify quantize of image, no method matching divided by 0 full of 64. Cool. Okay, we're getting there. So let's see, quantize 104 here. So we're saying box is equal to make octree, and then this is on line 64 here. We're saying naive bin. Okay, so now what's the issue here? There's a division somewhere in here. So we're going to say line 46. And here it says box CLR. Oh, we need another if equals to nothing here. So if box.clr is not equal to nothing, then we do this and try it again. Okay, so we got a bunch of images, and it looks like, yeah, it looks like we just screwed up our image. So if we do I am show of image 2, it's just going to be all, oh, that's not quite what I expected, but it's also not quite right either. So I've been doing this for a few hours now, about 3 hours. I almost feel like this is, it's not the best stopping point, but also I'm getting a bit tired. I know a lot of streamers go for a lot longer than I do, but I think it's about time for a break. So let me work on this for another like maybe 10 minutes or so. And again, if there's somebody that you want me to raid at the end of stream, let's see who's live. Skylius, I did Caitlyn just yesterday. But again, if there's somebody that you want me to raid at the end of stream, let me know. And we can raid that person. But yeah, like, again, like 10 minutes or so, I'm still going to kind of mess around with this a bit more. But I'm kind of at a stopping place. Like I'm a bit tired. So finding the color set right now seems to return all values of the same color. Like let's just look at our color set, and here let's remove this print line. Write this, go over here, and we're gonna do I am show here, and this gives us I am show. Sorry, we're gonna say image 2 is equal to that. And if we look at the color set above, my guess, I don't fully even understand how that color is possible. It's giving us a color that's in the negatives for some reason, and all the values are the same. All the values are the same. I could use some Bob Ross. Fair enough. We might raid. I don't know. It's weird to raid Bob Ross though. Like I don't know. I find that a bit weird. So this says to me that our color distance. No. This must be in the finding of the color set. So we find the color set, and how do we do that? So we find the color set in here. We say if index 1 is greater than color number, then we return. Then we're going to say they're barely any other good streamers. I don't think that's true. I feel like there's a lot of good streamers out there. Okay. So I'm just going to create some to-do statements in here. So one, to-do, what are we going to say? So first of all, some boxes return negative mean colors, which isn't great. The other thing we want to do is to do all colors are the same in the color set. Okay, so this is actually, I know I said to go for 10 more minutes, but I actually think this is where I'm going to end. So let's do git add source star, git status, git add, yeah, let's add project Otomo as well. Git status. Okay. Git status. And let's do git push. Origin. Oh, git adds. Git commit, sorry. Dash M. Adding skeleton for quantization. Okay. Now git push. Origin development. Okay. So this is now available in the development branch. There's obviously a lot of testing to be done. I put a bunch of to-do statements. We're going to knock those to-do statements out tomorrow. And then after that, we're going to focus on the other parts of the Quiltify. So I think that if we just sit down and we hammer it out, we can get this done in like 4 or 5 more hours. I know that sounds like a long time, but I think that's like one afternoon stream tomorrow. So if I do, how do I put this? If I just start streaming like 2 in the afternoon, I just stream all afternoon, I think we can go from there. There's a Quiltify. Oh, Quiltify instead of Quiltify. Yeah, I gotcha. Quilt and kilt sound about the same. Let's see. We've got. Yeah, we can try someone new. So who did you say? You said Gamozo? I've never heard of them before, but that's probably cool. Gamozo. Who is this guy? Let's see. Thanks for the stream. Yeah, we can try someone new. Otherwise we could do Skylius or yeah, let's do someone new. So let's go ahead and start the raid on Gamozo. That seems fine. He's usually writing fuzzers. Yeah, cool. Cool. So let's go ahead and start the raid on Gamozo. And that'll be it for today. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, when we hopefully work more on Quiltify. This has actually been super fun. I'm actually really excited for this. And I know it's kind of weird, but it's kind of the first time in a long time that I've done something that's just like creative for fun on the side. It's been a while, so I appreciate this. Anyway, guys, see you next time. Bye, guys.